Raz, raz, raz. Mhm. Aloha everyone. We're starting the day 2 of the Collabothon 2021. We're streaming live from Łódź. I hope you had a very productive first day and the night in case of some of you. Today I would like to shortly present you our schedule for today. In the 45 minutes we will start the set of the webinars. And obviously, all of you are invited to join our webinars as well today. I will also remind you today afternoon we are going to have the feedback session. The feedback session is not obligatory for you. However, I would like to encourage everyone to participate in the session because it's a very great opportunity to receive the interim feedback from our experts and from some jury members. It will be maybe the great opportunity as well to align some business idea for your application and for your solutions, and just to present the better application tomorrow. I would also remind you the GCP accounts prepared for this event are the temporary accounts, and the accounts disappeared few days after the event. That is why if you have your solution stored and deployed in the Google Cloud, prepared for the event, you need to download it to your private PCs or just basically copy the solutions to the private GCP accounts. We will provide much more information about the feedback session later on, so follow the information displayed on the Discord and follow this stream because you will receive a set of the useful information about the feedback session soon. I wish you a very productive day too, and good luck. Bye.
Okay, the time has come. Hello and welcome to the first webinar of the day, which will be conducted by me. Who am I? I will tell you a bit about myself in a second. But first, the title is Sentiment Analysis and Sarcasm. So today I will talk about the sentiment analysis, and then we will diverge into sarcasm to see how it impacts the task of analyzing the sentiment in the text. So who am I? I'm Patryk Pilarski. I am data scientist and data engineer. Currently, I am working as a data engineer at DocPlanner, and also I am a trainer, IT trainer at Sages. If you ever feel the need to contact me, it's quite easy. You can find me on LinkedIn, or you can directly contact me via email if you like. Apart from as a trainer, I do quite a lot of different things, mostly always related to data. I am also a co-creator of a great NLP course that is directed for Polish audience because it's in Polish and about working with text data in Polish. So I also have some different experiences with text, working with text, and today I will share a bit of light on how the landscape looks like when it comes to the sentiment analysis today. So what is sentiment analysis? If we would do some simple Google foo, we could find such definition. That sentiment analysis is the process of computationally identifying and categorizing opinions expressed in a piece of text, especially in order to determine whether the writer's attitude toward a particular topic, product, etc., is positive, negative, or neutral. So we have the definition. I believe that most people already have some idea what does the sentiment analysis entails. But to be sure that we are on the same page, here is the definition. So we have a text. We want to decide if the text expresses positive, negative, or neutral sentiment. And why are we even talking about this? Well, it turns out that sentiment analysis is one of the most popular applications of natural language processing when it comes to the usage of NLP in business in general. As we already know, it identifies the sentiment in documents. Most like documents, that's the quite broad name used in NLP to any piece of text of interest. So in case of sentiment analysis, documents are most commonly the comments that can be found on the internet, posts, and other such statements. And sentiment analysis is important for the business because it allows for fast reactions to signals from market. So if you are a business and you are selling your product, you will have customers, clients that will live partially in the internet. Like currently, as I've read somewhere not long ago, already more than half of human population is present over the internet. So there's a lot of our customers lurking there. So it would be good to keep an eye on what they are talking when they are talking about us, and what sentiment, how are we perceived? Are our products received poorly, or maybe they are perceived as a great investments by the clients? Of course, we could monitor internet manually, hiring a lot of people that would sit all day and read the comments over the internet, but that would be inefficient and very costly. So sentiment analysis allows us to automate this. Plus, it also introduces some standardization, because if we have a model or whatever system we would build, it will have set rules. For the same input, it will always return the same output. While if we are using organic humans, then different person reading the same comment might come to different conclusions. So sentiment analysis currently, especially as I mentioned, half of the human population is online, is done using some automation, some tools that we will look into how we can build ourselves. Because as it turns out, it's not really that hard. It's not super simple, but it's also not something that is crazy complex to have some basic solutions implemented. So business is interested in sentiment analysis, and when business is interested in something, then the workers, the people working for those businesses, will need to handle such challenges as sentiment analysis. So today we will look at how, using open source tools, we can implement our own solution. So sentiment analysis can be easy, but it also can be tricky. We can find a lot of quite easy and self-explanatory examples, like this trip was awesome. Like, we see that it's positive and there is no additional questions needed to be asked. It's very positive review of a given trip. And the next one, this laptop is great, but a speaker could be a little bit louder though. And so it's still positive because it's the laptop itself is great, but some salt was added here also. So it's not perfect. So still positive sentiment, but maybe not as positive as the first one. And we have, of course, cases that are obvious in the other direction. Like, it's a waste of money. It's quite easy to deduce that the customer, the client who bought the service, the product, didn't really like it. But the easy ones are easy. Most of the tools that we can use will handle them without any issues. But then there are some more complex cases, like for example, this phone is awesome. I love that it shuts down every 5 minutes. Like, looking only at the keywords, awesome, love, the system would assign the positive sentiment. Why is that? Because here we have a case of very nice sarcastic comment, and to understand it, the model, the tool that we would need to create would need to be able to understand the context that phones shouldn't really shut down every 5 minutes to be perceived as awesome. So there are cases which are not really that easy. One of the reasons when such cases emerge is use of sarcasm, and we are talking about data coming from internet most of the time, and over the internet, people quite often employ sarcasm in their communication. So then we have also different cases, like, for example, this tablet has good screen, but when it comes to battery, it's bad. So we have here both some good things and some bad things. In such cases, the question would be, should we average it out and say that it is a neutral comment? Or maybe our system should be a little bit more involved and be able to assign the sentiment values to particular objects mentioned in the review. So in this case, we would say that the screen in the tablet is great, is good, but the battery is bad. So that we have a more granular view on the whole. That is not something that we would talk about today, but it's also very interesting and could be of huge value for a lot of businesses. And then we have cases that come from straight from the internet lingo, like lit with exclamation marks mixed with ones. If our system is not prepared for the internet, it's not really, probably it won't perform that well. As I mentioned, most of the text for the analysis of sentiment comes from the internet, so we should be able to handle such cases and understand that the new, the cool expressions that are used, because they will be sooner or later used in the in reviews of our services or of our products. And then there is also a case like the last example on the screen. The weather was terrible, but overall trip was good. So we have here indication that something was really bad, and it was the weather. But should we consider this part of the trip? Like the company that's organizing, that's selling the trips, doesn't really control the weather. So if we see that the overall trip was good, should we consider this a positive review, or maybe again averaging out the sentiment from terrible and good and go with something more neutral? That's another topic. That's another question, and it's another problem to solve. Again, today we will be mostly concerned with the cases like the first sentence, first review from not so easy group. So this phone is awesome. I love that it shuts down every 5 minutes. So sarcasm. So as we can see, there are cases that are very easy. There are cases where the things are not that easy. And it's not only that they are not easy for machine, but also as human beings, we can have some problems with determining if the given sentence is talks good things or not really good things. I can say that I had pleasure of working on a project where I was collecting data from comments under some posts. This was done in Polish, and I needed to sit down and read a lot of those. And it's not easy to read them, and it's not easy to come to come to the conclusion with other people if given text is expressing positive or negative or neutral sentiment. It's not always black and white in such cases. So sentiment analysis as a whole, like most cases, can be easy, but some of them will be tricky. And as I mentioned, we will look at what approaches can we take to implement our own solutions to tackle sentiment analysis tasks. So there are two main approaches. The first one is a dictionary-based approach, which, as the name suggests, is based on the dictionary. So we would need to create a dictionary with mapping. Okay, word good is related to positive emotions, positive sentiment. So we would assign a score that would indicate that the sentiment should go up in the direction of positiveness. And words like worst would have indication that the given word is not really positive, so it should lower the score. So that's dictionary based. We will delve a little bit deeper soon. And then there is AI based, like machine learning, deep learning based approach, where we can, depending on how we define our target variable, we can go with regression or classification families of models. It all depends on a given use case, but in most cases we go with classification. And what does that mean? Let's look at how we can define the target variable, so what we want to predict. So here we have a couple of quite common cases. So the simplest one is the first one. So we have two classes, so classification, positive and negative. Depending on the majority, like the sentiment of the text, we want to find out if it's positive or negative. This can be useful if we are working in a very polarized area. Why? Because in normal cases, in most cases, not every comment, not every review must be that positive or that negative. quite often most of the reviews, most of the comments will be rather neutral. So that's our second case here, where we have three classes: positive, neutral, and negative. So we have this class in the middle, still in the classification side of machine learning, but with more than two classes, in this case three. Then we can also utilize the star system, which can be found quite often in different stores online. So again, we may be interested in how would a given customer, given client rate given product or service on the scale of 1 to 5 stars, where one of course will mean the lowest score and the 5 the highest. But then we can also go with the regression approaches, and here the options are quite unlimited, because we can go with the scale from 1 to 0, from where 0 means negative and 1 positive, and all in between can also be used. It can be useful to apply the regression approach, as it gives us some more flexibility. We don't really need to say that, okay, this is super positive and this is not this is super negative. We have the wiggle room in between to assign some continuous number, and then most likely someone will need to come up with some cutoff points to make it more actionable. So we can go with different brackets, like from 0 to 1, from -1 to 1, or from 0 to 100. It doesn't really change that much. Again, we can define our target variable, what are we interested in, as a continuous value, so that we could apply regression models to solve this problem. So this is the target variable, and now we will look a bit closer at different approaches that can be employed to solve our problems. So the first one was the dictionary-based approach, and as the name implies, it requires a dictionary, most often tailored to the business use case. Why is that? Like, we can find quite a lot of words that are positive in general or negative in general, but when we are working in a specific business domain, we quite often will find words that are not in general negative or positive, but in the context of given business, they quite often are. So for example, if we would work, I don't know, in library and in the club, and we would encounter a word like quiet, in context of library, this would be most likely positive word. Why? Because we expect libraries to be quiet so people can read. But in the context of a club, if it's a dance club or whatever, then maybe quiet is not the best word that can be used to describe nicely prospering club. So quite often we will be interested in customizing our dictionaries. We can find quite often for many languages dictionaries with the generally accepted words that are positive and negative. So we can use it as a base and then extend it with our own custom business case related words or even sentences, because it's not sentences or some bigram, trigrams, so connected to 2 or 3 words, because we are not really limited to only working on the single word level. Going with the dictionary-based approach, we will most likely use the knowledge of SMEs, subject matter experts. Why? Because they will be the greatest input that we can have to extending our dictionary. What is great about dictionary-based approach is that it doesn't require training data. Why? Because the only thing that we need to prepare is really the dictionary. And if we have the access to SMEs, they, even without having a vast vast data sets, they can tell us what kind of expressions are used regarding our product to say that it's good or not really good. So we don't really need training data, which is a big plus when we are starting to think about implementing such solution as sentiment analysis solution, and we never before stored such comments. Another great thing about dictionary-based approach is that it is easy to implement. When we have a dictionary, which we can implement in any modern programming language in the form of dictionary or hash map or whatever it's called in your preferred language, then it's as simple as going word by word or like bigrams, so 2 words, 3 words at a time, and checking if given word or word combination appears in your dictionary. Take the score of the given word or word combination and combine it to form the final score for a given sentence, for a given document. So there are quite a lot of pluses. The dictionary-based approach quite often is a good start. Like we can implement it quite easily and have something that brings value. It's not like most likely it won't be the best of the best solution that can be done, but it's easy, simple, and quick. It has some drawbacks, of course. Like, for example, creating this and updating the dictionary can be labor intensive, but it's not like crazy intensive. We probably would require to meet from time to time with SMEs to maybe update the dictionary. At the beginning, creating, if we go from scratch, creating the full dictionary that is usable in our use case may take some time, but it's not that big of a deal. Then, when going with the dictionary-based approach, our accuracy may not be perfect. Why? We are working on the word or combination of word level. So we are not really able to handle complex relationships in text. So simple cases we will handle flawlessly, but when the not so easy cases appear, we will most likely have some problems that are not really solvable using simple dictionaries. The other thing worth mentioning is that currently, if you mention that you will go with the dictionary-based approach, your solution most likely won't be deemed fashionable in current world. Of course, we shouldn't base our actions on how they are perceived by the rest of the world, but that's something that's worth mentioning. Again, starting simple is quite often, almost always, good idea. So dictionary-based approach as a starting point is good too. It's a very good choice. But again, there are some limitations that cannot really be overcome using simple dictionaries. So then we have the second approach, AI-based approach. And here we will need to have training data, because we will need to train our model. So that can mean either collecting our own data or looking over the internet to find the appropriate data sets. I will mention talk about some more about this in a second. With the AI-based approach, we can handle more complex relationships in text. So not only the easy cases can be solved, some more complex one, maybe not all of them, because as I mentioned, some cases are hard even for humans, but more complex ones also can be handled correctly. Which means that our solution will be more accurate most of the time, unless we created a really bad model. The other thing is that we don't really need to reinvent the wheel, because we can use models or neural network architectures that are commonly used. So there are best practices on how to approach a given topic. So we can have some directions on how to approach our use case in our business. Another great thing is that quite often we can find some pre-trained models which will mean that maybe we don't really need that much of the training data to start with the AI-based approaches. But here, the availability of the pre-trained models and their performance may differ between different languages and between the models themselves. And since currently we have quite a lot of tools that are easy to use, it's relatively easy to implement, to build a model that will handle sentiment analysis. But there are some drawbacks. When it comes to the training data, collecting the training data is quite often costly and time-consuming, because it's not only, okay, we need to have a storage for storing the data, but also someone will need to go through each of the text, each of the comment, and assign its score. If we want to have a good labels, we will probably need more than one person to go over the set, so that they can come up to agreements in more troublesome cases. The other thing is that we can find some training data over the internet, but there are two cases. Like, training on data out of domain might not give perfect results. Like, for example, if we are in the business of manufacturing and selling cutlery, and we would use the model data that is talking about reviews of movies, I don't really see that much of the common terms used between those two domains. So it's best to have the data from our domain, so collecting the data. But it's not like that out of domain data is completely useless. It can be used, and there are papers, there are approaches that show that models trained on out of domain data can perform quite well. But then there is other thing. Even if a data set is available over the internet, it doesn't necessarily mean that we can use it, because different data sets have different licensing attached to them. Some of them are only available for academic purposes, for learning, and not really for using in business cases. Another thing that is still not solved, like there are no as of now generally accepted best practices is the product analyzation and monitoring of AI models. So creating the model itself can be quite easy. Like, to handle the basic cases, not the hard ones, but creating a basic model is quite easy. But then pushing it to production is where the challenges can manifest themselves. And making the model work in production requires to monitor it. We would need to retrain the model after some time, because the language used over the internet changes quite rapidly. So we would need to be able to seamlessly switch from model to model and stuff like this. So there's a lot of challenges. There is a lot of progress in this domain, but still, if we are using strictly open source tools, it will require quite a broad skill set and imagination to make things work as we would like to. Then using AI models, they can have quite high hardware requirements, which translates into costs. If we go with very deep neural networks, most likely, even for inference, if we want it to be fast, GPU or TPUs may be necessary. So either we pay some extra money, or our model, even if it's performing perfectly, may be a little bit slow. So there are trade-offs when it comes to the accuracy, how good our model is, and other business requirements like costs and timeliness of delivering solutions, delivering the predictions. So there is it's not that simple that we should always and only go with the latest and greatest networks, because there are other things in life that matter than simple accuracy. And now we'll take a look at how it could look like if we would apply the classical machine learning. So in the classical machine learning, I mean the regression, logistic regression, trees, forests, and stuff, models like this. It's quite easy. Right? Currently, in most cases, we would go with scikit-learn, which makes our life quite easy because we have a lot of ready-made classes that will allow us to either train a model or prepare data to be able to train it on the model. So here we have a simple few lines of code that would allow us to create a model for classifying text. Of course, it's simplified. So in real world scenarios, we would need a few more of those, but it's to show that the core using appropriate libraries is quite easy to tackle. So we import some classes, then we instantiate the object. First is the count vectorizer, which will allow us to split each text into separate words and create a nice matrix for our model to work on. Because machine learning, it doesn't matter if it's classic one or the deep learning based. It's mostly matrix multiplication, so we need matrices. So this count vectorizer allows us to transform a set of documents into the matrix. Then we instantiate the model, train the model using simple fit method, and then we are able to make predictions. So it's quite simple. But we will need to create a few of those, test different hyperparameters of our model to come to the best that we can find. But then there is also deep learning approach, and with deep learning, what is not so common, or at least almost not common at all, is that with the deep learning models, quite often we can find pre-trained, ready-made models that we can just grab and use. Again, it's worth to look at the licensing of a given model, because not all of them can be used in business settings. But it is possible to find models that are ready for a task that we are trying to solve. So here I am showing you the import from the transformers library from Hugging Face, which allows us to, in one line, import a full pipeline that will deal with sentiment analysis. Here, the model is BERT-based multilingual uncased sentiment. It's, as the name suggests, a BERT-based model, so it's transformers, so latest and greatest architectures of the networks for working with text. And having such classifier, we are able to pass raw text, raw reviews, and get the results, get the information on how on the sentiment, assign the sentiment to all of the text. It's worth mentioning that deep learning models quite often have some limitations on the length of the input text. So if we have lengthy reviews, that might not be the best case for deep learning models, because, like, for example, this model that I am importing on the screen, in the code on the screen, has a limitation of 512 words. So if the text is longer, we would need to trim it, remove some words from the end. But again, the deep learning based approaches quite often will give us the best performance, of course, at the cost of more higher requirements on the computational requirements. So here is an example of the output. If we would pass the example reviews that we have seen on one of the previous slides through this classifier pipeline, we would see that first three of them are perfectly assigned. So first is 5 stars rating, The second one is a 4-star rating, and it's a waste of money, it's 1 star, so it's perfect. But then the interesting things start to happen. For example, this strictly sarcastic one gets the 5 stars rating. Why? Because you really need to understand what is fun, and that it shouldn't be shutting down every 5 minutes to be able to catch that it's not really a positive review. Then we have the one with the good and bad things mentioned, and we receive the medium score. So the model went with the neutral class. The lead one, apparently our model never worked with wordings straight from the internet, and never found such exclamations of how great the given product is, and gave the review 1 star, even though it probably should be a 5 star. And the last one, even though the weather is not part of the, like, it is part of a trip, but it's not something that the company can sell and control, we get here a neutral rating. So it's not perfect, but for the easy cases, it almost never misses. So that's great. Plus, no training was involved. The only computational costs are associated with inference, so using the pipeline that we have downloaded here. So as we can see, the most interesting for us today one, the sarcastic comment was completely misunderstood by the model. Why? Because sarcasm is not that easy. So let's go to the sarcasm itself. And what is sarcasm? If we would look for the definition in Cambridge Dictionary, we would find that the sarcasm is the use of remarks that clearly mean the opposite of what they say, made in order to hurt someone's feelings or to criticize something in a humorous way. So we use the same words as when we are speaking positively about something, but we mean completely different thing. No wonder that models have problem with that. I must admit that I can use sarcasm, but I am not really always able to detect sarcasm. So I am not blaming models too much. But what can we do? What more can be said about the sarcasm? Of course, sarcasm is very easy, as we already mentioned. So of course, this is sarcasm, and it's not easy not only for machines. It's not directly connected to any particular words, because we can use the same sentences as sarcastic or not. It all depends on the context. Sometimes sarcasm can be signaled via some cues, like "yeah, right, you are always great," and stuff like that. But they are not necessary for sarcasm to emerge. And so sarcasm emerges from context. We need to understand what we are talking about, so that we can detect sarcasm. And when it comes to the sarcasm, there is ongoing research on, and new papers are published quite often tackling this problem. The approaches are different. We can find data sets with sarcastic and non-sarcastic comments, mostly coming from Twitter or Reddit. But still, it's you cannot say that it's a solved problem. But we can find some ready-made models. They may not perform perfectly for our cases, but in general, if we are interested in finding something that is usable and has some validity to it, we can find such models, such tools. Here I am showing a short snippet of code that utilizes the Spark NLP library to create a pipeline that will first, we need to pass our input text through the document assembler. Then we need to encode sentences. So again, ready-made tools from Spark NLP library. Next, we load the pre-trained model for detecting sarcasm. Under the links that are in the presentation, you can find more information on which data sets such models were trained and how well their performance was on such data sets. And that's almost all. Then we put all of those steps into the stages of our pipeline. We have a pipeline. We need to pass through it, even simple text, just to make that pipeline trained, even though we are not really training it. And we have a pipeline that can be used to detect sarcasm. And what about results? Well, in our case, they are not really great. The data set on which the model was trained was a bit different than the cases, than the expressions that I used here. So some of them were detected positively, like something that wasn't sarcastic wasn't get the label of normal, so no sarcasm detected. But some things that were also not sarcastic got the label of sarcasm. The good thing is that the sarcasm was detected in our most sarcastic review in our data set. But looking at the labels that we have here, we cannot really say that in our case, on our data, this particular model performs super well. But again, in different contexts, using data sets, using data more closely resembling the training data of the model, we would probably achieve quite different results. Different meaning better. So that's the thing. We can find the models, or we can be inspired by papers that are published, that we can find that are constantly coming, then constantly new ones are coming, to implement our own sarcasm classifier, and then having model for sarcasm and model for sentiment analysis. We could combine them. So if our sarcasm detection found out that a given text is sarcastic, then probably we would lower the score from the sentiment analysis, or even flip the switch other way. So if we have only binary classes from positive to negative, or in different directions. So combination of those two things may give us better results. But again, in the perfect world, we would have a sentiment analysis model that would be able to also deal with sarcasm. Unfortunately, as of now, and as of my research that I've done in this topic, there is still not. I haven't found a model that would be able to do those two things together perfectly. So perfect solutions doesn't exist, but we have tools to experiment and find the combinations of different tools that we can quite easily implement ourselves to have the solution best for our business use case. And to my webinar, there is also a notebook which lists the code examples. We can take a look at it because there is not much left in the presentation itself. So it's a Google Colab notebook. So in the presentation you will find a link. You can always open it yourself and look through it. So here are some examples of using, in this case, large movie review data set, and how to train simple models or use the dictionary-based approach. Here I am using a ready-made Python package that packs a lot of dictionary entries into it and allows us to score full sentences. And here we see that, for example, for a data set that I used here, the accuracy is not perfect because it's binary, positive or negative. So 67 is not that far off from random, which is 50. But again, it's, for example, for sure knows something about sentiment and polarity in text. Then a simple machine learning based approach. Here I used a decision tree classifier. The examples here, I set a limit to myself what can be implemented in 5 minutes of time. So that's why there is no hyperparameter tuning. I just wanted to showcase that it's quite simple to build basic things. And in case of this model based on decision tree classifier, the accuracy is better than the one achieved using the dictionary. And the last one that I showcase here is deep learning based. So here I load the pre-trained model, and then I needed to cut long text shorter because of the limitations of the model itself. And then another problem that I encountered was that when I tried to pass all the text through the classifier, the RAM available on the machines under the Collab notebooks didn't handle it, and I needed to split it into the batches that were passed through classifier. But all in all, the final accuracy of this approach was definitely better than the one based on the decision tree. But the costs, the time that it took for this loop to finish, it was around 20 minutes. So it's some GPUs or other or strong, better machines would be preferable to have a nicely crisp and fast solution. And when it comes to sarcasm, here is code that allows you to recreate what I've shown you when it comes to the Spark NLP pipeline. So definition of the pipeline, creation of the pipeline, and usage of the pipeline on a data set that's built from those sentences, and the output when we have both the document and the there shouldn't be a sentiment. That's my mistake. I will fix it. It should be sarcasm. And again, we see that the predictions are not perfect. But coming back to the presentation, because I already took a bit more time than I should. Conclusions. Implementing solutions for sentiment analysis can be easy. Because of the availability of easy-to-use libraries and availability of pre-trained models. We don't really need to write that much of the code to have things working. But easy handles easy. So if we want to handle more complex cases, we will be more involved in the collecting of the data, training different models, testing different approaches, and stuff like this. So creating basic solutions using the open source tools is quite easy. But then handling all potential challenges is still an ongoing battle. Example being detecting sarcasm is, of course, extremely simple. And again, I am sarcastic here. And that's all from me. Thank you. I put thank you through a classifier, and it told me that it's positively, the thank you is a positive sentiment. And it's not really a sarcastic comment. So thank you. I need to mention also the SigDelta. So SigDelta is a brand of Sages. So if you have any needs concerning data analysis, machine learning, or big data, you can contact us, and we will be able to help you. So we crunch data. Thank you. I believe that now, if there are any questions, I can answer them. Great. Okay, do we have any questions? Tak, dziękuję. Thank you for the nice words. So maybe since I believe that I can use the remaining 10 minutes, we can switch back to the notebook, and I can talk some more about the code that is there. So let me go back. And what is happening here in all of those cases, we have in the first approach is dictionary based. So I am using the Affin library. It's a very nice library, but it's only for English. So if your needs are in different languages, then you would probably need to create your own either library or just a dictionary. For English, quite a lot of good quality dictionaries are available. And since the Affin gives you a numerical score, you need to have some threshold. So here I set a threshold to 0. So if score from Affin is higher than 0, then I assigned such record as to positive class, so the positive sentiment, and if it's lower, then to negative sentiment. Of course, modifying this threshold, probably we would be able to achieve a bit better or a bit worse accuracies on the whole. Then in the ML-based approach, the count vectorizer, as in the slide, was used, but I needed to adjust some parameters. Here they are controlling the number of they are limiting the most common words and the least common words, because if the word appears everywhere in every document, then it doesn't really give you much information about how to differentiate them, the documents, the sentiment of the documents. And if the words appear only in 1 or 2 documents, then it is very risky to use them, because we can overfit our model. So just simple limiting of the higher and lower end of the commonality of the words, which gives us at the end the quite nicely looking matrix, which then is passed to the decision tree classifier. Here I am using the random state to set a random state, so that whenever I rerun the model on the same data, I get the exactly same results. It's quite important, quite important to have random seeds and other things like this set, so we have reproducible results. So training to one line of code in here, and prediction, as we have seen, it was a bit higher. Again, using different model, tuning hyperparameters, we should be able to achieve quite higher results in here. Then the deep learning based approach, I used the transformers library and pipeline, pre-trained pipeline, in this case NLP Town. We can always check on what data it was trained, and here is the link that you can follow to more info about this model. This model is nice because it's you can use it for different languages. Of course, depending on the language, the number of training data was different. And if we look at the accuracy that was achieved using this model on the training data, it's not perfect, as we can see. But if we are okay with being off by 1 star, in this case, we see that the results are quite good. And so that's another thing here. And when it comes to sarcasm, the model that is used is available. People from the people responsible for NLP library, which is John Snow Labs, they trained this model on. Yeah, we can find the data which was used and how well it performed on this data when it was trained. So we can find always more information about available models, either in this case on the Spark NLP library and here searching through the Hugging Face model repository. Another great place to look when we are interested in finding good results is papers with code, where we can find papers and the code accompanying them, and we can get inspired in implementing our own custom solutions. Okay, so if there are any questions, then I'm happy to answer. And if not, then I believe that's all from me. Okay, so okay. All right. So I will give you some more time to ask questions, because I've learned that there is some lag between YouTube and Restream. Okay, so I see there are no questions. So thank you. I hope that I was able to share some interesting things with you. Again, I am Patrick Pilarski, and if you ever feel the need to contact me, you can find me on LinkedIn. Thank you, and bye, and have a great conference, great Collabothon. Bye.
Okay, hello everyone. Aloha. I have my Hawaiian shirt on, so I think we can start. I will be sharing my screen. You should be able to see the presentation now. And I think just for, okay. So let's start. We will be talking about building chatbots or dialogue assistants, specifically goal-oriented chatbots using open source software. First, few words about me. My name is Ryszard Tuora. I'm an NLP developer. I work with Institute of Computer Science, Polish Academy of Sciences, and also with SAGES. And I work mainly on corpus processing tools. I work on dialogue assistants and also on question answering. Okay. So we will be talking today about goal-oriented chatbots, and goal-oriented chatbots should be distinguished from conversational agents or open domain chatbots or chatterbots or however you wish to call them. The idea behind goal-oriented chatbots is that they are not there to attempt to pass the Turing test. They are not supposed to mimic human conversation. They are rather interfaces through which you can fulfill some goals that you might have. And these goals might include, for example, a financial chatbot or a banking chatbot could help you do money transactions, could help you learn about your history, and could help you block your credit card if you think it's stolen. So these are the things that have real world consequences. And when we evaluate goal-oriented chatbot, we are interested in how efficient it is in achieving these real-world goals, not in whether the conversation is really very natural. Okay. So I thought about how you could utilize goal-oriented chatbots in the tasks that have been proposed for this hackathon. And I came up with some very basic ideas. So for the ecological effect of plants and the smart and sustainable lifestyle, you could build sort of a general purpose chatbot, which could, general purpose informational chatbot, which could give some information from some APIs, from some databases, from some document bases, do some question answering, and so on and so forth. So this chatbot could be an interface which would give people personalized information regarding questions they might have regarding the needs for information about particular topics, right? Then for the next generation virtual workspace task, I had this idea that you could build a dialogue interface for your solution. So, for example, a personal assistant for a home workspace, which could take care of some contacts, of some meetings, of some stuff like that. Okay. We'll be working today with Rasa, and Rasa is an open source integrated framework for building dialogue assistants. It is Python-based and is language agnostic, so you can use it to build chatbots for Polish, for English, for any language you wish. It can also be easily integrated with Spacey, which can provide these linguistic capabilities from the outside. Okay, so if you have a niche application in some language, you can get ready-made linguistic models from Spacey and build them into Rasa easily to get the capabilities in the language you work with. Okay, Rasa is essentially a no-code system, so you could, in principle, build a chatbot just by editing text files, but it can be extended using Python. So it can be extended in two ways. First of all, you can define arbitrary Python code for executing different actions by your chatbot. And second of all, you can extend the pipeline that is used in the chatbot via some Python extensions, so that you can get more conversational, more linguistic capabilities using some Python code. Okay, and Rasa is also easily integrable with popular messaging software such as Messenger, Telegram, or Slack. Now, let's talk a little bit about architecture of typical chatbots. So usually they are built in a pipeline fashion, and which means you have a sequence of components through which information passes sequentially, so one after the other. Okay, and you have usually three components, that is natural language understanding, NLU, dialogue management, DM, and natural language generation, NLG. And let's talk a little bit about the first two ones. The last one, and the natural language generation component, is not really that important in goal-oriented chatbot because, as I've said, naturality, the naturalness of the conversation is not really that important. Okay, so we'll focus on the first two. NLU is tasked with building structured representations of messages from the user. And these structures usually consist of two things. So you have two tasks for NLU usually, and these involve, first of all, sequence classification, which is recognizing the intent behind the message. So you get a message and you want to put it into one of the predefined categories, right? So here we have a message, great, I'd like to order a large pepperoni. And we have a pre-made category for messages like that, which is called order pizza. And your chatbot should be able to recognize that this message falls into this intent. Okay. Then we have the task of extracting objects mentioned in the message, which is essentially sequence tagging. And this consists of finding some words or some tokens or some phrases which refer to things which are important for our application. So in the case of a pizza chatbot, you obviously have to know what type of pizza you are talking about, what size of the pizza you are talking about. So it is nice if a chatbot can extract this information from the messages themselves, right? And these both are standard NLP tasks, so they are quite well researched and developed, and the state of the art is quite satisfying at the moment. So you can really build something quite easily with that respect. Okay. Now the dialogue management component is tasked with first of all selecting the actions which need to be undertaken based on the current message and on the history of the messages. So based on how the conversation develops, you want to select what the chatbot should do now. And this may involve just linguistic stuff, so how the chatbot should respond, what should the chatbot say, and it also can include some real-world actions which can execute, as I've said, some code which can bring about some real-world consequences. And also in a ideal setting, your dialogue management component should also be able to track things such as detours. So if your conversation partner has a different subject he wants to talk about for a second and then come back, the chatbot should be able to handle that. And also if a person who wants to correct some mistake that your chatbot made, for example, your chatbot was mistaken in extracting some entities and remembering some information, it should also be able to handle that. Okay, so that is all with respect to the presentation. I will show you some of these slides, but I think Patrick has already shown them to you. So now we will quickly maybe look. Okay, I don't see any messages in chat, so I think we can continue. So we will be working mainly via the command line interface. I hope that you are able to see it right now. We will be working with Rasa. Rasa is a Python package, so you can install it via pip, doing something like this. But I've already installed this, so I don't need to execute this. And afterwards, you should be able to do a thing like that, Rasa init, which initializes an example of a chatbot. But what we'll be doing is instead we will be working on a chatbot that I've already prepared for you. So it's it's available on my GitHub page at Collabothon repository. And if you want to work with it, please clone this, although you will not be really coding anything right now, so you can do it later. But all the information, all the presentations, and all the files are there for you to access. And this is how what you will get is supposed to look like. This is the basic chatbot, and as you can see, it's mainly composed of some YML files. YML is a format for structuring information. It's similar to XML. And I will now guide you through the different files and what do they do. First of all, let's look at the config.yml file. And config.yml is it contains the definition of the pipeline itself for the chatbot. So the pipeline is composed of different components, and these components can perform different tasks. So for example, you have a tokenizer which splits a message into tokens, which roughly correspond to words. You have a range of featureizers which convert these words into vector representations, okay? And you have some extractors. This is actually a custom component that I've written, and you will also look at this later on. You have a diet classifier. This object is a dual intent and entity transformer classifier, so it handles the intent classification and entity extraction at the same time. And you have some other components for post-processing here. And also you have policies specified here. And policies correspond to dialogue management. So these are memorization policy, TED policy, and rule policy. Rule policy is a deterministic policy. Memorization policy tries to find whether an identical conversation path has already been seen in the training data, and if so, then it just simply follows the training data in this respect. And here we have also a machine learning model which can learn to classify, to choose the best possible action in the circumstances that happen during the conversation. Okay, the credentials file contains your credentials for connecting to external servers such as Facebook, such as Slack. So if you want to integrate your solution with some external app, this is the way you should do it. We have also the domain YML file, and in the domain YML file, we draw up the representation of the world as it is to be seen by the chatbot. Okay, so everything that the chatbot has to take into account should be specified here. And here we can see we have a list of intents that the chatbot is supposed to be able to tackle. So we have different intents. We will look into what each of these does in a moment. We also have entities to be recognized and slots where the entities are put into. Okay, and this is, in most cases, it is a one-to-one mapping, but these are not exactly identical. So you can see, for example, person name, sex, age, and email are mapped straightforwardly into person name, sex, age, and email slots. But we also have, and the same also applies to a country entity and country slot, but we also have additional slots such as infected, which is of a different type bool. And we have a QA answer slot, which is used internally by the chatbot itself. It's filled by the chatbot, it is recovered by the chatbot, so it is not really something that the user has direct input into. Okay. We also list all the actions that are defined, and these are non-linguistic actions, so actions which actually execute some code. And we also have a thing called a form. A form is essentially very similar to a form that you build on a website. So it is a set of questions, it is a set of data that you deem necessary for some particular application. So it's necessary for the user to provide you with this set of data before you proceed with something. Okay, and here this data is represented as slots. And the slots are the person name slot, the sex slot, the age slot, and the email slot. If you look at them, in most cases, they are of the type from entity, which means that an entity is recognized and then it is simply put into the slot. Okay, so these are the one-to-one mappings, but you also have the case of the infected slot. An infected slot works differently. It is filled by particular intents. So if you recognize a agree intent, or an affirm intent, it will be mapped to the value true. And if you recognize the deny intent, it will be mapped into the intent false. Okay. And also we have some ready-made responses for the chatbot to use. And NLG in Rasa is fairly simple. So you either use ready-made messages that you write yourself, or you will can do some simple template filling. So here we fill a template with the person name, right? So we take the value of the slot person name and we fill it into this message to send it to the user, send it back to the user. You can also see that we follow some naming conventions, and the most important ones are the ones regarding the form that is here. So this is called the vaccination form. And you can see that the names here follow closely the names of the slots. So the questions that we are going to ask will be automatically paired with slots for the form to be filled. Okay, I should mention this. I forgot to mention this. I don't know why. The chatbot that we will be building is a simple chatbot which can be which is based around the COVID pandemic. So it is supposed to be able to deliver some basic information to people regarding the COVID pandemic. And it is called Covidius, and we've built it in Sages as a sort of showcase, a demo chatbot. So let's look at other files. We have the endpoints file, and this one is where you define external ports that you will try to connect to. And the most important one here is the action endpoint, which specifies the way you will connect the action server. So in Rasa, the conversation and executing of actions are separated, and Rasa offers a server for running the actions themselves separately from the conversation. So we will run the server, and then it will be accessed via the conversation components via this webhook. Okay. We also have the requirement file where all the modules are contained, which will be necessary for you. And these are the basic files that we will be talking about. But now let's talk about data. So the data folder contains 3 files. It contains the NLU file, rules, and stories files. And the NLU file contains training examples for the chatbot. So examples which are supposed to give the chatbot the ability to recognize certain intents. And you can see the structure is that we write an intent name and then all the examples corresponding with that intent. And we have the greeting intent, the goodbye intent, we have the affirm intent, which says yes, the deny intent, and we also have some intents related to the COVID itself. Okay, so I prepared few intents like these. So I have the get regulations intent, where a user might ask what are the current regulations, what are the restrictions right now, and so on and so forth. We have the get API intent, and this intent corresponds to the user asking for the numerical data about the number of cases and number of deaths in some country in the world. Okay, so you can see examples. Are there many new deaths? What are the stats for Croatia? And so on and so forth. We have an abilities intent, and this is sort of a meta intent. The idea is that if your user is starting talking to a chatbot, he might not really know how to proceed, or they might be frustrated because they've already tried different things and nothing seems to work. So they might ask a question like, okay, so what can you actually do? And we should be able to recognize this and then list some of the functionalities that we are able to do so that the user can use the chatbot in a more guided fashion. We have the vaccination intent, which is something like a user would like to be registered for vaccination, and we can then collect some data which would potentially be could be used in signing them up for vaccination. And we have an inform intent, which is quite specific, quite different from the other ones. The idea behind the inform intent is that if you build a form, if you look at the way the form is actually executed, the form asks a sequence of questions, right? So we have these questions defined here, and these questions are simple questions. So what is your age? What is your sex? What is your name? And so on and so forth. And users will usually not reply to these in a full sentence, but they will just usually list they will just give the answer to the question itself. And this is what the inform intent is for. So for messages we just want to answer a simple question, I want to fill some particular form, we have things like I'm 18 or 50 or male or John Peters or things like that, or my email is john@kobak.uk, okay? And this is the syntax for marking entities within Rasa. So you have the square brackets for the intent itself, for the entity itself, and you have the round brackets which specify what type the entity falls into. So we have the age entity, we have the sex entity, we have the person name entity, and the email entity here. Lastly, we have the QA intent, and this intent is just corresponds to some different questions that the user might have, which will be handled differently from other intents, and we will see in a second how that happens. In the rules file, what you have here is actually just simple rules for selecting actions based on intents. And these rules are deterministic and they are context independent, so they work like this. So if you have one message of this type, just respond with this action. So these are one turn interactions. So if you have the get API intent, always reply with action API. If you have the get regulations intent, you always reply with auto regulations. You also can do conditional execution of rules. So we have two rules which govern how forms will work, and the first one corresponds to the activation of the forms. So you recognize that the user will want to says that they want to be vaccinated. So you start the vaccination form, you activate the loop, and then Rasa takes the execution from you. It does it automatically. So it asks all the questions corresponding to all the slots automatically. And then after all the answers have been given, after all the slots have been filled, you execute this. So the condition is that we are within the vaccination form. And if the vaccination form was filled, we just deactivate the loop and we utter vaccination form filled, which is a message which confirms that your vaccination form has been filled and has been sent to someone. Okay. You also can give training examples to the dialogue management component. And these, for example, consist of stories, which are longer interactions. So here you can see a 3-turn interactions, which start with a greeting. The bot responds with a greeting. The user asks for abilities. The chatbot states what his abilities are. And then the user asks for the present regulations, and the chatbot responds with what are the regulations at the moment. Okay, and we have also a QA story, and this works as follows. First, the user sends a question, which is recognized as QA, and then we do the action QA. And action QA it can answer your question, but it can also, in some circumstances, want to ask you which question you had in mind. And in this case, the user will say that, well, I had this question in mind, not the other ones. And then only then it will answer the question using the action QA answer. Okay, so let's look at how the actions themselves are executed. And this is the Python code that I've wrote. So this is just an extension of Rasa itself. And first of all, let's look at the action API class. The general idea is that your action should be a class which inherits from action, and it should return, it should have a method name which returns a name which corresponds to what you've defined in the domain YML file. And then you have a method called run, which takes a few parameters, few arguments. And here you specify what actually happens during the action execution. And afterwards, you have to return a list of all the events which happen during the execution, which should be taken into account by the dialog management component. And these events which should be taken into account usually involve setting some slots to some particular values. So because we do not set any slots here, we just return an empty list. And the logic here is that we have an API which can give us information about a particular country, and we just get the message, try to get the value from the slot country. If no country is specified, we just assume Poland as the default country, and then we format the API address accordingly. We get the data, and we create a message which specifies what the numbers are. So yesterday in this country, so many people got sick and so many people died because of the coronavirus pandemic. If we are unable to get the data, then something must have gone wrong. And we say, I apologize, but I couldn't find data on this country. Maybe you've made a typo. Okay. And this is based on country extraction, which is done via a custom component. I will show you this one in a minute as well. Okay. And now let's look at the question answering, how this one works. So we are using external vectorization tools here. We use a sentence transformer to generate vector representations for questions. And we use cosine distance to calculate similarity between questions so that we can find the closest one. So the idea is that I've scraped some questions from a FAQ database from Center for Disease Control. And I've scraped this, you can see these questions here. So this is essentially a list of questions paired with answers. And the idea is that we get a questions from the user, and we try to find the most similar question in the database, so the most similar question from these ones, and then we return the answer which corresponds to the most similar question. If there are many questions which correspond to the question from the user, or if so if there are more than three questions, if there are three questions, if there's more than one, if there's more than one question which passes a threshold that we've set, then we give the user a opportunity to choose which question they had in mind. Okay, but this only happens for the top three. And if no question passes a threshold, we say that we weren't able to understand the question, and could the user please rephrase it in some way. So what happens here is we load the vectorization model, we load the ready-made, the pre-calculated vectors for all the questions that we've downloaded. We generate the data structures which will be used to recover questions and answers. And then we define the action itself. So the question answering is split into two actions, the action QA and the action QA answer. And the action QA works like this. We get the question itself. We can generate the vector for the question. We calculate the distances, the cosine similarity between different, between the question from the user and all the questions from the list. We saw this generate a ranking and use a threshold of 0.4 distance. And then if there is any question which matches, we execute this code. If there's no question which matches, we just say, I couldn't understand your question, can you rephrase it? But if we do have some questions, we then essentially recover the answers. Okay, so we recover all the answers, and we consider a different question, whether there's only one matching question at the ranking, or if there's more than one. So if there's only one, we just return the answer which is paired with the question, and we utter this as a message. If there are more than one, we say, please select the question which best matches your inquiry, and we generate some buttons. So this is an option that Rasa gives you. You can define some buttons which the users might click, and upon clicking such a button, this will be understood immediately without any NLU. This will be understood as an inform intent, and the inform intent will try to fill the slot QA answer with the index of the question that the user deemed the most similar. Okay, so this is how it works. And now let's quickly look at the country extract itself. So this is a custom Python component for extracting countries out of data, out of the messages, and this works very simple. We just have a list of all the country names. And then what we do is we simply use Levenshtein distance to calculate the most similar sounding country to the one specified by the user. So we get all the tokens from the user message, and if we are able to find a token which corresponds with some country in our database in a way that they are only apart by one character calculating the Levenshtein distance, then we decide that, okay, they had this country in mind, so put this country into the country slot. Okay, this happens. Essentially this works so that we define for some methods which are not really used in our case because our model is not trainable. It is deterministic. There's no machine learning here. And also, we don't need to save any data to disk, so we will not use these methods. We just define them as pass operations. And what is important is the process method, which gets the message, and it splits it into tokens, and for each token, it tries to find a matching country. So it looks at the Levenshtein distance from all the countries in the database. It creates a ranking, and if there is some top country, then we return this country. Okay, and if we get any entities, we set them using these methods. After converting them to a format which is required by Rasa. Okay, so this is essentially how the chatbot works. Now we can look at how we can use it. So first of all, we need to run the action server, and then we will run the Rasa interactive command. And Rasa interactive is a way of talking to a chatbot, which allows you for some debugging as well. So you should maybe look at all the command line utilities via Rasa help. And you can see that you have Rasa init, which initializes a basic chatbot. You have Rasa run, which starts the server itself if you want to already deploy your chatbot. You have Rasa shell, which allows you to talk to the chatbot via a command line interface. You have Rasa train, which trains the chatbot on your data, which you've supplied. And you have this interactive functionality, which we'll use now, which trains the chatbot on your data and then allows you to talk to the chatbot, giving some debugging capabilities. And we'll look at how it works. So you can see that the server for actions is already running at this port, and then we trained in this case, NLU model didn't need to be retrained. We just trained the dialog management component, and after the training is done, we will be able to talk to our agent. Okay. So let's wait a second. Okay, so we can talk with our agents. So let's just do all the things in sequence. So first we can say hi, and we can see that the NLU classified this as intent greet. It recognized no entities. This is correct, so we press yes. Okay, you can see the confidence here. You can see the slots values here. This is what I meant by debugging. And the bot wants now to utter the action greet, and this is correct in this case. So the bot responds to our hi with, hey, how can I help you? And then it runs the action listen, which just means that it waits for our input. Okay, so we will ask the chatbot now, for example, about the restrictions. Okay, so I want to know about the restrictions. And the chatbot, the chatbot answers with, it recognizes the restrictions, the regulations intent. So this is correct, and it utters the correct message. I should probably increase the font size. I should probably do this earlier. I apologize. Okay, so the regulations are then uttered to us. So here we just send a link for the user to visit. And now let's, for example, ask for what is the number of deaths in what country can we come up with? Okay, so for example, Argentina. Okay, what is the number of deaths in Argentina? Okay, and the intent has been recognized correctly, and no entities were labeled. So you might be puzzled as to why Argentina has not been labeled, but if you will see, it is just the case that it happened after that the recognition happens after we get this prompt. So the slot actually has been filled with Argentina. The country is recognized as Argentina. So the action API is now run via the action server, and we get the following data. Yesterday in Argentina, 19,000 people got sick and 456 people died because of the coronavirus pandemic. Okay, so we see the situation is quite serious. Now we can ask, we can proceed. So, for example, let us ask some answering question. So, for example, we want to know whether can I get COVID from my dog? And this is recognized as a QA intent. And so the chatbot wants to run the action QA. And we see that in this case, more than one question has been selected as possibly relevant. So we have the question, can I take my dog to a dog park? Can I take my dog to daycare or groomer? And can I get COVID-19 from my pets or other animals? So in this case, the third question is the most relevant one. So I will select the button corresponding to the third question. And then the action QA answer is to be executed, which recovers the actual answer paired with the 60th question. And so this happens based on the available information today. The risk of animals spreading COVID to people is considered to be low, and so on and so forth. Okay. Now, for example, we can say that we want to sign up for vaccination. So I would like to get the vaccine, and this will make us come into the form. Okay, so we are asked the first question, what is your name? And we can say, my name is Adam Smith. Okay, and you can see that here it is not the entity extraction module has some difficulty, and this is because I have not given it enough training data. Usually things like entity extraction are more involved, more difficult, and so you either want to give the model more data, or you want to use some external components which can recognize entities more efficiently. But let's pretend that this is okay. So our person name is recognized as Smith, and then the second question is asked, what is your sex? And I will respond with my sex is male, for example, and here the entity is recognized correctly. So it asks another question: what is your age? And we will write like 50. Okay. And now it asks us whether we've undergone the coronavirus infection. So here it is not based on entities, as you might remember, but it's based instead on intent. So I will say, no, I have not. And this is correctly recognized as deny. So the infected infected slot will be filled with false, as you can see here. Okay. Now it asks me for my email, so I'll just say as.at@gmail.com. It's covered, and then all the slots have been filled. So the chatbot wants to run the after vaccination form filled action, and this just says your submission has been registered, Smith. We will get back to you. Okay, so these are the sort of capabilities that our chatbot can achieve, and I hope that I managed to show you that it is really quite easy to get this sort of results from your chatbot. So all you have to do is essentially edit these text files in a proper way, to structure the conversation. Think about how you could structure the conversation for the chatbot so that it can be it can flow easily, and then you can have a functioning dialogue interface to whatever application you might want to pursue in your project. So that is all with respect to the demo. I will now maybe, if there are any questions, we will get to those. Okay, well, if we have no questions, I think we could end here. I don't really have anything more prepared for you. If something comes up, please message me on Discord. Maybe I will try to help you in whatever way I can. The repository is for you to use, so you can look at it as a demo of how to achieve particular ends, particular solutions, particular effects. So I hope that it may prove useful to you, and I think that will be all from me. Okay, so I got the message that I will be supposed to end now. So thank you all for your attention. I hope you will have a good time at the rest of the event. I hope that you will achieve fruitful solutions and you will get all the prizes. Good luck and goodbye. Thank you.
Hi, hello. Does anybody hear me or something? Okay. I cannot see anybody else than me, so I'm not sure if there's somebody's with me. Okay, but I will start. So basically today I wanted to say a little bit about some kind of method of optimization of the processes when we started to connecting the two things, which at the beginning was very difficult to combine. The first thing is the analytic side, which is where we are like analyzing the data from the system like SAP or something else, and then we are trying to match it somehow with a psychological point of view. So we are trying to find connect those data with the people behavior in the company. So today I will speak a bit about how we are doing it and what we can find it during the making this method. Maybe you will find some, I don't know, some way to use it in your job or in your company or something else. So basically we are focused on 4 tools. The first tool is interview, which is provided by my partner in company. She's making interviews which are like focused on 2 things. The first thing is how people feel about the company, how they feeling about the job they are doing, and what is the main purpose of the job which they are making. Basically, from this side, we know that people are satisfied or not from the job which they are doing, and when we are finding the things which they are satisfied, we are trying to find it in the job to make it more things that they can find the more time to be more satisfied from job. And from the second side, which is the bad things which we are finding during the interviews, then we are trying to find the reason why these things are happening. Basically, what we know that people are doing some things in the jobs which has different background, and the main thing which we are doing based on rest of those 3 tools, we are trying to find the reason why they are work not efficient, or they don't like their job, or what they can do to minimize the things which they don't like in the job. The second tool is MOS. This is the multi-observation study, which means that during one day we are standing next to the people or the team, and we are checking every minute what they are doing. So this is the way of looking for the other's job from the other perspective, not from their side. So even people are thinking that they are making lot of tasks. Basically, we are not focusing on the tasks. We are only focusing on the events which they are doing. So, for example, we are asking the people, "What are you doing?" They say, "I don't know. I'm working on some kind of project," but we can see that they are not doing this project, but they are talking with other people. They are going to coffee break. They are making many other things which are not connected with the project which they are thinking that they are doing. So this is the way to find out what is the real number of the events, and what is the real number of tasks which they are doing every day. This is the way where we are focusing on the people. We are talking with them, and we are trying to find out by being next to the people. Then, when we have the data collected from these two tools, we are going to next tool, which is Jira. We are using Jira as a analytical tool, not based on the managing the projects, but we are taking only the data about the hours and about accumulation of hours in the projects and in the tasks. So we are not like we are not. We don't look like, as a Jira as it is. We are looking on only on the data side, and then we are combining everything in Power BI to find some to check data and to find some correlations between interviews, Moses, data from Jira, and to show it somehow to the people to try to find what we can optimize in the processes in the factories or in the offices. Basically, we are using all those four tools, as well as in factories. Right now we have a project in one of the factories which is producing some electronical parts, as well as in the offices like IT developers like offices or some kind of small startups, marketing offices or something like this. Of course, we try to start to use it in different kind of services like hairstyling or cosmetology. So we are trying to develop those tools not only in a common point of view, but we are trying to find some other ways to find how we can improve the methods of working in the companies or in the offices. So the first thing is what we are looking for is starting to find out how much time we are spending on value-added events, how much time we are, which is the green area, how much time we are spending on the yellow events, which is not value-added, but this is the not value-added tasks, but they has to be done because we cannot make it without we cannot make any value-added things without these events. And the red ones is totally things which are totally not necessary in every job, but you can see it that the percentage of those things, for example, in most of companies are about 30% or 35%. Once we have found the project which we have 60% of every hour spent on the things which cannot be done. Let's say people are doing it, but they can do it, but this is not anything which is like putting any value in the work area or in the project. It's not moving project forward. So basically, this is the first step to analyze why people are have those not value-added things in their jobs. Of course, the yellow ones is the crucial ones which we are trying to find out in the interviews, how we can manage it to shorten those things. We know that we cannot totally move it, but this is the things which can be automated basically, and this is the information for startups which would like to automate some processes. Basically, this is the nice way to find on the client side what is the processes which could be automated somehow to improve the jobs, because those things are necessary but not necessary do it by the people. And those red ones is events which can be deducted at the beginning, and it has to be we have to focus how to stop to do it. And this is the way that we are looking the way to optimize processes and to improve the work. In this case, we have a company where people in each hour they spend about 10 to 15 minutes on the coffee breaks, cigarette breaks, or they just leave the office because they don't have a job. So we found that in this case we try to make the different way of working, the different way of putting tasks to the people, because they don't have a job, so they move from the office to the other sides because they don't feel that anything can be done in this time. Just after that, we are trying to find which hours during the day are the best hours to work. This is it's based on the people's behavior. Basically, everybody has some kind of internal clock. Some people prefer to work at the early morning. Some people prefer to work evening. Some people prefer to work during the day. But nevertheless, most of us has to work between 8 to 5. But in those hours, we are not the same like efficient all the day. So we are trying to make those analyses 2 or 3 days, different days during the period of the project, to find if it's possible to find some pattern which can be like which shows in most of the days which we are looking for. This is the project which we have only 2 days to develop, perform the most. So we found that the increasing of the value-added tasks was at the end of the work or just before the break. So they had the break before just about 2 p.m. So as you can see, if someone wants to go to the break, they felt that they has to finish some kind of task or some kind of job to not blame themselves that they are going somewhere. And this is the same thing that is happening just at the end of the day. So we try to find a way how to deduct the number of the non-value added, those red things at the beginning of the job. So we found that every day at the beginning of the job, they have some kind of problem with the planning of the task which they have to do it during the day. So every day between 9 to 11 they started to plan the job. So this is it was crazy because even they plan it 2 hours later they has to change the plan. So because they like the new tasks which are coming every day, they cannot forecast it and they cannot plan it anyhow. So they started every time that the new jobs not finishing the old ones. So we found that when they could plan the day not at the beginning of the day but at the end of the previous day, it increased the number of jobs which they can do next day. So this is we found it during the MOS and we found it during the interviews from the psychological point of view. When we show the graphs to the people during interview, they started to open and they started to talk why they are doing this way and why is it why they don't like to do between some kind of hours, so we can change the number of hours which they are planning every day and which they are working every day. Next, we are switching to Jira and we are trying to find some things which everybody knows that we are doing it. So this is the not planned jobs. This is the red color on the graph. So as you can see, this is the graph from the 1 month only. So everybody is working about 160 hours every month, and somebody is working less. But as you can see, almost 20 to 25% of the time, everybody's time is a time which they are consuming on the jobs which cannot be planned. or are putting in the schedule by their boss. So this is the nice graph, because during the discussion with the boss, he told us that they are not so efficient. They cannot finalize their jobs in the time. Even they are promising that they will do something, they cannot provide it next day or in the time which they promised. When we showed this graph to him, that 25% of everybody's day, everybody's job is making him happy. So he started to think to change the way of planning of the job, and to talk with the people, and to plan the project. So as you can see, so at the beginning we made the most. Then we made the interview, which people told us that they have a lot of things which are planned by the boss, putting in the ASAP method, and then we can find it in the Jira, in the kind of plan, when they submit the hours in the Jira. So this is the way what we can find to change the behavior of boss and to change the behavior of people to plan their jobs. And finally, we try to find how they work in every project. So this is the graph which I don't want to say, but if you will look on your own job as a job based on colors, every day you have some colors in your job. Every hour is every different color, and you can only use 8 or 10 hours every day to make it to colorize it somehow. Then you can see that everybody in the long period of time has almost the same graph. So if you will try to find some kind of pattern, which how you are working every day, how the colors are representing you every day, then you can start to optimize the methods of works which you have in your everyday working, and then you will try to deduct the number of tasks which are not influencing on the job or finalizing the task which you are making. So everybody's placing the data to Jira, but they are not analyzing it. So I recommend to every manager which has a team to start to analyze the data, not only by if the people finishing the jobs in the time, but also how they have how many colors every day they have to place it in the schedule of their day, because if there is more colors, the more tasks you make it, then it's less possible to make everything in the good way. So in my opinion, during the day should be maximum 5 colors, not more, not less, because if you have less, then we cannot make everything which probably is in our job. If we are making more, then we cannot focus on each task, and that's why we have stress, and we have some kind of problem with concentration and making things done for us and for our clients and for the projects. So I didn't translate this one. Sorry. When I will send those materials to you, I will translate it in English. But basically, what we started to do in one of the bank, it was M-factoring. We tried to optimize the process of signing the new contract with for the factoring product for new clients, and we tried to deduct the time. So at the beginning, when we started the project, everybody is don't know exactly what they do every day. So at the beginning, we try to find what they are doing, and we try to find what is the volume of things which they are doing. For example, how many meetings with the possible potential clients they have, how many transfers of money they're making every day, how many calls to the people with cash handling they have to make it, and so on and so on. So we try to develop some kind of indicators which we can monitor every day. So the people stand every day next to the table, next to the whiteboard, and they discuss it about what is the performance of every team and what is the performance of each people basically in the team. If they are like deducting the time of issuing and signing the contract, or they are like making it longer. So the method of works was at the beginning we try to find why they are like not making it in a proper way or in the time which they would like to do it. Then we started to start a meeting every day next to the whiteboard to find the progress of each project or the progress of each process. And in the first stage, we found that the people started to look for the optimization by themselves. So at the beginning, optimization begins from the people, and then there is a number, and at the end, the people has to like take it in their own hand and start to optimize by themselves, because every company, like our company, has to like go out from the client, and client has to do it by themselves. So we developed with people the number of tools for them, which are like necessary and fit for them to start monitor their job and to improve their job every day basis. And during the other projects, we try to like find if every project is made this the same way, because we would like to find some kind of standard of making every project. Even the company has only 2 products. Right now they have 5 projects which they are making. Even the products was like standardized, but we can see that each project is making a very different way. So right now we are trying to make one standard for each project to like to categorize projects, to categorize some kind of events and tasks which has to do during this project, and to find out which task will be like value added tasks and not value added tasks, and then plan how many tasks which can be done during the project to maximize the value added tasks. So what I want to say is that from the discovering phase, when we are like trying to find why people behave somehow, we are trying to like make some kind of standards based on this behavior to reduce the stress in the people's behavior and in the teams, because most of the stress is coming from situation that they are not like they are not concerned, or they are not sure if they are doing job in a proper way. So we are trying to find what does it mean, the proper way, and we are trying to develop some kind of standard to show people how is the proper way, and when everybody will be satisfied, and when the client will get the project on the time, and how much money has to be spent, or how we can budget the next project based on the information about hours and the tasks which they were done at the previous projects. And this is probably the last slide, and what I wanted to say is that every project has some kind of pattern. At the beginning, there should be like more hours spent for the like discovering the clients' needs and discovering the way of working, or making some tools which has to be done. And at the beginning of each project, for sure, you will not like have a money, because even you will budget the project at the beginning. For sure, you have to like spend more time for the project. The best way is when at the beginning you will spend more time, and in the future, in the next days, in the next weeks, you will like spend much less time, basically every week. Unfortunately, what we can see in most companies, that the graph is totally different. At the beginning, people don't like spend much money. They spend not much money, not much time to discover every issues and every aspects of the project. Then there is some kind of phase that I call this phase the panic phase, where everybody like see that the I don't know. The deadline is coming, the results are not okay, and everybody's like putting more efforts in one project, which influence all the team. In this case, we have one project which calls me SubMe. During 2 weeks almost, they spent 5 people on one project. Even they budgeted only 1 people to manage this project and to develop things which were in the contract. Unfortunately, the one person didn't find everything what has to be done. So to cover the situation and to be okay next to the client, they have to engage all of people in the company to resolve the problem which was made at the beginning of the project. So what I wanted to say is that even we are focusing many times in the projects on the technical point of view, on the tools, or we are trying to find the things which can be done only using our intellectual side and tool side. I would like to put the stress that even though we are the people and we are behaving somehow, and our behavior is almost the same every time. When we have a time, we will procrastinate. When we don't have a time, then we will focus on the task, and we will do it in much more efficient way. So what I wanted to recommend is to start to think what is your own pattern of working, and to convince by you and for yourself that this pattern is making some value for the company, and this pattern is coming from your psychological point of view and from your technical point of view, and from I don't know, doświadczenie means so I don't remember this word in English. Maybe I will try to recover it. So basically, during the optimization process, we started not only to look for the indicators, KPIs, numbers, and so on. We try to find why people has such numbers, has some kind of performance in analytical point of view, and when we are trying to find it, then we try to learn the people that they are making they are making the job in some kind of way, and they should understand the kind of way what they are doing, because then they are starting to be more efficient than not only when we are looking at them by the numbers perspective of view. So so that's it. Basically, what I wanted to say is stop looking at us as a people only by the numbers and KPIs. Stop to do it. Start to be more human, and start to be proud So is there anybody who has a question or some kind of issue?
Hello again, can you hear me now? Is it okay? Perfect. Okay. Aloha hirahi, and it means good evening and or good afternoon. My name is Szymon. I will have a pleasure to run today's feedback session, and hope you had a great time since then, and it's time now to put the cards on the table. So let me introduce you briefly to the rules. We have 8 minutes for each team. First 3 minutes for the team, literally the captain of the team, to tell us about how do you want to face the challenge and what is your progress in your work. And a kind remark from the jury: please do not use the PowerPoint. Just be yourself, express yourself without slides, as it always works better. And you will receive 5 minutes feedback from the jury. Okay? And we are connected. We have in studio, we have Marek Gajowniczek. Hello, Marek. Hello to you. And Mrs. Karolina Jaronowska. Hello, Karolina.
Hello, welcome.
Hello. Marek and Karolina are from Commerzbank. Marek is chief of DTC Łódź, and Karolina is head of HR unit in Commerzbank. And we have also online Alexandra. I can see you. Okay, we have Krzysztof Zalasa. Hello, Krzysztof. Aloha.
Hello. Krzysztof Zalasa from Google.
Krzysztof Zalasa from Google Cloud Poland, exactly. And great to see you guys. And we have 10 teams formed. Ola is not already with us, but she joined us later, I suppose. So we got 10 teams, and we are ready to feedback session. I can see Mark Kruger from EcoPoints would like to start this session. So guys, you got 3 minutes starting from now. Hello, Mark.
Hello, everyone. I would like to share my screen to show you a prototype, actually. So let me try to do this on the second account. So maybe someone can. I'm trying to share my screen right now. So if not, it's okay. Huh?
It's okay.
Can you see something?
Yep.
Okay, so our idea was to use the data a bank obtains from a customer and also implement other stuff to implement some form of point system which allows us to reward sustainable behavior. Yeah, and I will just show you actually our prototype if we go into the app. It's maybe a bit tough to see for me right now, but so our idea is that we start with a landing page where you have a progress way, and every time you do something sustainable, you get another point for that, which you can later use in the shop and spend on stuff. Yeah, and we think that one could obtain, for example, transaction data from the banks, and every time a customer buys a train ticket or goes to a certain ecological grocery stores, they get some eco points. Yeah, and also we will reward if you have a portfolio which is focused on ESG investments, if you have a mortgage loan which is for a green mortgage. And then based on the transaction data, also we want to provide our customers with tips to lower their carbon footprint and also make us some money. Yeah, for example, we know the transaction data, what kind of water supply or utilities provider it has. So we can, for example, offer them to switch the provider, lower the carbon footprint, and give them some eco points. Yeah, and or for example, if there are government projects, we can also offer them something. And the second part is that we want to reward activity, because, for example, health insurance companies, they really like if you are a sporty person, and they encourage you to be sporty. And in Germany, at least, they will reduce the fees you pay there. So we thought we can also integrate that. And for example, if you walk every day, you also get the eco points and do something for that. If you use the public transport, you get the eco points. Yeah, and in the end, you can spend the eco points for sustainable stuff, for train tickets, for example, for sustainable clothing and something like that. Yeah, and we think that there are many ways to monetize this. Actually, for once with the corporation partners, because you have customers which are very environmentally friendly oriented and usually are able to pay more. So we think we can make some form of deal with the merchants to get some kickbacks. And we also think that, for example, governments, health insurance companies will allow us to get some form of kickbacks so we can provide those rewards. Yeah, that's our basic idea.
Mark, thank you. Mahalo. Guys, what are your comments? What do you think? What do you want to ask Mark and his team?
Maybe I have one question. The question about how it will be connected to the external world. It is just like a API for all the companies that would like to offer something as a payback for these eco points?
Yes, so on the one hand, the input data, we also, this was just a click dummy we shown. Yeah, we also work on the back end, and we get, for example, data via PSD2 from the banks, and then exactly just in the API where, or just like partnership landing pages with the companies who want to be able to receive eco points, we're going to do that and connect it in that way. Yeah.
Okay.
Regarding this data accessibility, because receiving the data about the credit about the loans from the banks or even the water providers, etc., it's kind of I can say sensitive data, yes. So did you make some research about if the banks or the providers are?
Yeah, I can give you an explanation on that. So I think there are already a lot of apps who do this, but not in a sustainable way. So in Germany, we have an app which is called Finanzguru, which is like a financial assistant and analyzes a lot of your transaction data. So, and also Commerzbank, for example, has something which goes into that direction. So there's definitely the possibility to use this kind of data. However, at the moment, it's just used to, for example, maximize the return on investment and something like that. But we also want to use this to reward them for sustainable behavior and thus increase the usage. But I guess definitely we can use that.
Mark, I really like the idea. It looks really good. I'm wondering if maybe because this rewarding part, which impacts behaviors of participants in the program, looks really good. I'm just wondering if you have considered maybe some kind of being more expressive about this carbon footprint. So not only about, points, but some kind of, presenting that, 1,000 eco points means that you will reduce it on this value or something like this. It's in order to really present this impact on the environment, not only just, be rewarded.
That is definitely a very, very good point. I think it will be tough to translate eco points directly into a CO2 reduction because we obviously work with partners. So we think, for example, if you invest in a certain fund, you get 100 eco points. Yeah, and this will not equate to always the same amount of carbon dioxide reduced. But I think we can definitely implement something in that direction which presents the data. Yeah, I think that's a very, very good point. And in the financial way, we can just extract the data which we already do for the eco points and do that. Very, very valuable point for us. Thank you.
I can add that I really like this idea about expressing and using your sustainable activities and then rewarding this activity. So I really like it. And maybe in the future we can even use, because you show from the individual side, but we can also even I can say move to the company, yes. So not the individual, but as employees of the certain of particular of the company, that also we can compete between the companies, yes, about the sustainability activities. So it's really we can. I see that the future, yes, of the application, that we can even use more.
Yes.
Yes, of course. So this is very private customer heavy, because also this gamification aspect, which we want to include with streaks and that kind of stuff, where we really want to motivate the customer. But yeah, I can absolutely imagine this also being used for corporate clients, because the algorithm, for example, to use to determine how many echo points per transaction can also just be copied to the corporate clients. Yeah, I think this is maybe something we can add in our presentation as a roadmap.
Mhm. Great, Mark. Mahalo, thank you very much. Thank you guys for comments. Hope it will help. Hope it will be helpful for your work. And now we'll have a short break, as our organizer asked to some technical break. We will return in 5 minutes.
Thank you.
Thank you. Thank you very much, Mark. Ciao. Hello again, aloha. Well, still ready to and waiting for you to join the feedback session. We are with our experts, with Marek, with Karolina, Krzysztof, who want to hear your story, your progress of your work, and give you feedback. So we are ready. Please join us. Show your work, your problems, and your visions of how do you want to face the challenges of the Collabothon. We are ready. We are waiting for you. Hello again. We got next participant, team. We got Christian from Coffee Talk
Hello.
team.
Just do this if you can hear me, people, please.
Yes,
can you
we
hear
can.
me?
Yes,
Okay, perfect. Well,
Great.
then let's start. Hello, everybody. I'm Christiana, and I'm going to be presenting Team Coffee Talk to you today. So what are the biggest challenges in home office? One is the loss of informal information, the kind of information that's just flowing around the room because you're in an open space and people talk. What does it do? Well, it makes interaction more difficult, and it makes a lot less spontaneous. So what can we do? We're making sharing information as easy as talking, and we give you a possibility to ask questions out loud and get answers, not from your cat, that is the usual in the home office, but from your colleagues. So how does it work? Well, I'm not going to go into the details today because this is just the feedback session on the idea, but let's say this is a hackathon, not a Christmas market, so there's going to be AI, and it's going to be based on tools that are already available in the bank. Why is that? Because we're talking data protection, we want a quick setup, and we have an eye on the cost. So what can Coffee Talk be used for? It is a tool to make for better team communication. Why do we want that? Because communication increases the efficiency. We want to make the existing information available without freeing up colleagues to do days and weeks of documentation. We want to get the knowledge out of the heads and into a space where people can find it. And, well, we are IT, so it can be used for spontaneous coffee breaks as well. Do we have any side effects? Yes, but they're positive. We're avoiding language barriers by putting spoken word into the systems. It can be translated. We're having accessibility improvement because it can be read by a screen reader. You don't need a sign language translator for certain colleagues, etc. And it also gives a way to make the communication happen at the person's own personal pace. They communicate when they want it, and it still gets to the colleagues who need it. We also have a keyword filter that avoids spamming and getting bing, 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 bing message every 5 seconds. So if you're interested, please stay tuned and ask your questions.
Thank you, Christian. And
hello. I need to get into the.
Are you with us?
Just a second. I need to find out how to get back into my YouTube. There. Thank you. I can hear you again now.
Okay, perfect. So we will give now the floor to our jury experts, Karolina, Marek, and Krzysztof. Can you hear us?
Yes, very well. So maybe I will start with the first question. Christine, I really like the idea behind it. And can you hear us?
Can you hear us? Please confirm us, Christian.
Christian, sorry. Echo.
Oh, now I can hear you.
Perfect. Okay,
perfect.
So Krzysztof has first question.
Yeah. First of all, a very interesting idea. So thank you for bringing it to the table. I'm just wondering if you have an idea how to, let's say, group people together, right? Because when we are talking, we are chatting with some random people in the office. It has, from my observation, at least from Google Office, it has, let's say, two flavors. We are chatting with our teammates, and it's the first way of communication. We are asking for something for project, but sometimes we are also talking with some random people from, other teams, other levels of organization. And I'm just wondering how you would like to tackle it in order to, do not introduce a lot of mess, but in order to bring the chance to mix ideas with people even out of the team, or just sitting close to us.
We're going to start on a team level. Just go this way if you can hear me, please.
Yes.
Okay, perfect. We're going to start on a team level, but we are going to branch out to the ability to set up other rooms with other teams if you're interconnecting. But first, we are starting on a team level because it's the communication within the teams that's the most impacted by the home office phase.
Okay, thank you.
Thank you. Marek and Karolina, do you have any comments, maybe questions? Karolina, you are chief of HR unit.
Yeah.
It's very close to you.
Can you hear me?
Yes, perfectly.
Yeah? Okay, Christiana, because I have a question. What is the differences between, for instance, MS Teams chat that we using within the Teams and your application, your solution?
This is a low-level entry barrier. When you have a Teams channel, you need to type out your question. So you have to think about, how am I going to formulate this? How is the person going to get this? What we're trying to do is have a low-level entry. They just hit a button and record a message the way you would just open your mouth and talk in the office. We want to get the spontaneous part back into the conversation, not think about it 3 times, just get it out, ask the question.
Okay, nice.
So it's informal channel of communication.
Yes, but it also has the added impact that afterwards the answers you get can be searched. So we get every question that is answered gets knowledge out of single people's heads and into the group mind, into the swarm intelligence, if you wish.
Marek, you have a lot of programmers, developers at home office. How do you find these solutions? Would it be helpful, useful for them?
I think that the idea at least should be tested, because as I got it, please correct.
Oh, we miss you. Something wrong happened to... I will give you information for the technical stuff.
No? Yes. Garbage. Okay. So
okay.
My question is, if I understand it good, it is a kind of the chat, but without typing. This is like you can say something, send it, and then wait for the answer. Yes, is this the idea?
That is part of it, but we're using speech to text, and we're putting in hashtags which make it easier to search. So we want the information available for everybody who has access to that information. Okay. Hence the team factor at the beginning, because we're talking data protection as well.
Honestly speaking, I would like to test it. So because it might be a very good idea. Of course, I think that the whole team should be prepared for using such a tool. But I see it as a good add-on to the systems like MS Teams.
So if I can add something more, is it kind of like the common ontology you will create and common hashtag common for this community working on similar issues with similar problems in work or in close to the work areas? I mean, when you are not in the office, you have similar problems that perhaps guys from working from outside the office also. So this is this kind of idea. Yes.
Yes, to get the team to interact spontaneously as they would in the office. Just, oh, where was that folder where we had all this interface description? Or do you remember we had something about a bug in this or that? What was that? Do you remember? Like, just asking out the question instead of thinking, okay, who am I going to send this to? Am I disturbing them? How do I word this? Just belt it out. Get the communication going.
I have one remark, yes, because right now we have a lot of meetings. We have meetings after the meeting, so I think that when we will have a lot of questions, yes, really simple questions from the team members, where I can find this folder, this file, etc. So it could be kind of the frustrating and this I can say disturbing in your, I can say, routine, yes, in your calls, etc. So maybe you could also show and more, I can say, how to organize, how to implement it in your daily life, yes, in your daily work.
Yes, absolutely. We thought about that, and we have what we are thinking about is several filters, as in I only want to see questions that have certain hashtags, like, for example, I'm responsible for system XYZ. So only if the question contains XYZ, I want to see this in my feed, for example. Or I can say, I don't want to be disturbed at all today, so I can just unsubscribe for a day from this channel and get back to it another day and have a look at what has been going on. So information density is definitely a factor.
Great. Thank you. Are there any...
We lost Christian?
No, we have Christian still. She's waiting for your comments and next questions. We can give her some more time. I think, as there are no other teams in the queue, and we had some technical problems during this session with Christian. So, Krzysztof, Karolina, or Marek, do you have any other comments or more questions? No? Okay. So
I just wonder, I mean, is it intended to have on PC or also on mobiles, or?
For the moment, we have thought about PC, but then again, since we are, for the moment, we're working on a Teams integration, so mobile would be thinkable since Teams is already on the bank's mobiles as well, but this is not going to be for today.
Okay, great. Thank you very much. Thank you, Christian. Mahalo. Wish you success in this project. It looks very interesting. Sounds very interesting. Wish you all the best and see you tomorrow.
Thank
Ciao.
you. See you tomorrow. Bye-bye.
Bye-bye. Thank you.
Thank you. Bye.
Thank you.
Okay, so we are ready for the next team.
Hello.
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 So, hi, I'm Laura from Team EcoServe, and I'm ready to present our project to you. So, everyone knows everyone knows that cars leave a carbon footprint. But I myself wasn't aware that by doing web research, I also leave a carbon footprint, and it's not a small one. If the web was a country, it would be the 7th biggest polluter in the world. I mean, this problem is huge. So, sorry. Fuck. Can I start again? I forgot to share my screen, sorry.
Okay.
Yes, of course.
Yes. Laura, calm down. It's okay.
Okay, so
You can start again.
Can you see my screen?
Yes, now it's we can see your slide. Okay.
Okay.
It's Google Challenge, etc.
So, okay. Everyone knows about cars leaving a carbon footprint. But I myself didn't know 2 days ago that we leave a carbon footprint by doing our web researches, and quite a big one. If the web was a country, it would be the 7th biggest polluter in the world. I mean, this problem is really huge. So let's see. We have this challenge. I mean, like I said, I myself didn't know about it. So there's no awareness of the users. Only little people know about this problem. And additionally, there is increasing data usage. So we're using in our daily life more and more data. So it's already the 7th biggest polluter. But in a few years, what will it be then? Will it be the first polluter in the whole world only by doing the web researches? So, for example, when I Google something, for example, I want to buy a dog, so I will Google dog. Then, yeah, I don't know which website is sustainability or is sustainable here. We have no clue. We can't do anything about that problem. So that's the moment we decided to create our solution, EcoServe. So it's a Chrome extension to increase the awareness about the user's carbon footprint and help individuals to change their web behavior. But yeah, let's actually see what it does. So if we go again to the browser and try to buy a dog, so Google for dogs, and okay, so it doesn't like to work now, but tomorrow you will see how it works. So we will see a small logo over the URL, and it will tell us that a website is, for example, eco-proofed, for example, uses green energy, or we also want to consider how big the size of the web page is, because that also takes a lot of energy. So let's see how our Chrome extension is supposed to work. Oh, okay. Let's see how our Chrome extension is supposed to work. Here, as you can see, we're Google for dogs, and we're sending it to a server. And at this server, we're checking whether we already validated it, because we don't want to produce more waste. So we're caching all the websites we already visited. So then we will check whether it's validated or validate on the factors I already told you. Then when it comes back, we will see the certified green host. And then we know that it's certified, it's green energy. And when I Google for dogs, I want to buy a dog, I can visit exactly this web page, and I will save a little of my carbon footprint, and I can improve the whole world with or if all users do this, we will reduce the carbon footprint of the world, and maybe we can do something about the big problem of the climate change with that.
Perfect. Laura, let us ask jury Krzysztof, Karolina, and Marek what they think about this idea. Very fresh, very original. Krzysztof, it's your challenge.
Yes, it is definitively, and I'm just wondering how would you, let's say, judge those sites? It's a challenge, right? Because in order to rate every single website in the internet, it might be significant. I'm doing it with my customers, some kind of crawling as well, not only as a Google, but also with my customers, and it's a technical challenge. So I'm just wondering how would you measure this, kind of being friendly or not friendly for hosting providers? Do you have any idea how to attack it?
You mean how would we give the certificate or like the badge on the website?
Yeah, exactly.
So as I mentioned, we have like 2 criteria already. So one is already implemented. You could see that. It's from an API with the Green Host Foundation. And
Laura,
they check
to show us something. Did you want to present us something? Because we don't see any slide. You said I'm showing you something.
No, I mean, I showed you when we did the Google research, there was this green badge. And this comes from the extension already. So there is two metrics, like the one I showed you back then. It's from this Green Web Foundation I told you, and they're checking for us whether a data center is using green energy or not. So we know that it's like green energy. So we say, okay, that's 1 point. So you did already a good job. But the other point, as I mentioned, is the size. And if the size, for example, is big because there are a lot of pictures or there's a lot of extra fancy stuff, then of course it takes more energy. And energy means more carbon dioxide footprint. So in the end, it means we have these two metrics and we validate them, and we have like, or we imagine we have a system, we will subprogram that with like different factors, and the user can see, okay, it's green energy, and on the other hand, it's too big, so the size is really huge. Maybe I won't choose that, but it will choose the one which is powered by green energy and it's really small because I only want to buy a dog or like get information about my dog, but not like see 100 pictures of dogs.
Okay, cool. And I have one more, if I may, obviously, in order to do not eat all of the time. But I'm also wondering if you considered some kind of, measuring it on customer side. So not only just be informed, but maybe introduce some kind of gamification on statistic or whatever. That, for instance, you visited, 10% of green sites today and 19 not eco-friendly, or maybe this kind of, feedback for the end users. I'm just wondering if you have considered this kind of approach.
So how we include the user in the whole thing? I'm sorry, you're like really bad understandable here. So I'm trying to summarize the question whether I understood it right.
So maybe I may repeat. So I'm just wondering, because I got the idea of this extension. I'm just wondering if you also consider some kind of measuring it. So measuring how many websites, as a user, for instance, how many websites I visited today, and how many of them fills those criteria to be, friendly, and how many of them are not meeting this criterion. To understand how my, personal browsing history today affected the carbon footprint.
So we want to do something like statistics. I mean, you can click, for example, on the extension, and then you can see that you're, for example, better than 60% of the other people who Google stuff. So you know that you're improving. And we're still thinking about that because we're still doing the MVP, and then we're doing this extension stuff. And probably we want to say you did, or you saved 200 grams of CO2 at the last week, and in this week you only saved like 150. Keep it up, keep it going, to include the user and to make him ambitious about using this extension.
Great, thank you.
Thank you very much, Laura. Great attempt to make web greener. Thank you for your time. Wish you all the best in your project. And any more comments or questions from Carolina?
Yes.
And Mark? Very short.
Yeah. I have one comment. I'm curious. What about the positioning the website in the Google? Yes. So if I search something, dogs or some would like to buy something, then I will be looking only for the website who has this mark with the green color, yes, and
exactly.
And then I'm afraid about the positioning, because I don't want to search, I can say, many sites. Yes, I would like to have it on the first page. Yes. So
Exactly. As you maybe could see at the example, when I Google Doc with our extension, you can see that, like, I think the first three results were green, and there were like one in between which wasn't green. But we have 1.4 million of green, or like of this information from this green energy side, and from that we have a lot of information about the page, so we can make sure that it's not like you have to go to the 10th result page to get something usable. I mean, there are a lot of results on the first page with different Google inputs, where you can like find a good example for using.
Okay. Carolina, are you satisfied with this
yes,
answer?
thank you.
Okay, thank you. Laura, thank you very much. It was very interesting. Sounds very revolution way of in order to change the behavior of the users of the internet. Wish you all the best.
Thank you
See
very
you.
much. See you.
See you.
Bye.
Yeah,
Bye bye.
bye. Thank you.
Bye.
Thank you very much. Aha. Okay, we will have just short break. Wait for next teams to present ideas, concepts, and progress in work. See you
Can you hear me?
Hello again. We are back. Hello to Krzysztof, hello to Karolina and Marek, and hello to Michał Katecki from Codebackers. Hello, Michał.
I want to get some feedback on our idea. So we are participating in this category about making the virtual workspace better. So our idea is to solve the problem of people not memorizing and not listening to the boring meetings online in the office. How we want to approach this is to make a feature that could be implemented really in any video call application, that you can transcript what is being said to a form of a chat, like for example, like on Messenger, and then we would use the AI to find the most important words in the text, right? What people are saying, so you can go back anytime, look at all the messages, and there will be a summary what this discussion was about, the main most important messages. Also, the users can pin the messages that they find especially important. So this is like meeting minutes, making them automatic, but having the all the information gathered to just have the most important content. So even if you're on a call and you're not listening, that somebody is talking to you and you missed something, you can live go back and see what that person said to you, and I think that would increase productivity quite significantly. Okay, so that's all from my side from presenting the idea, but I would like to hear what you think.
Thank you, Michał. And Marek, Karolina, it was your challenge, I think. And you are first addresser, so who should comment?
Yes, that's true. I think that the idea might be interesting. I would rather think about how to make it ongoing feedback more clear for the presentation or for the one who is speaking, to make it more interesting. However, as I understand it, it will be the same report or minutes for all the people. So it is like not individual approach, it is the session approach, yes?
Yes, it's the session approach, although people who want to pin some messages that they find interesting for them, they would be able to do that themselves.
So
like
it has like a common part and the private one, yes?
Yeah, exactly.
Okay, so might be interesting, especially how do you want to store it? Because with the minutes, we usually have it in a text form and then try to keep them somehow to get it recorded, so it will be also a text file?
Yes, it will be stored as text messages. The recording is a separate thing, but the most important part is. But what I think, because maybe we shouldn't store the messages on our in any database, just to keep it more secure and not to collect data. Just rather use the backend to just manage the traffic, and the messages could be stored. All the messages could be stored on the client side, so that it could be safer, but maybe it's not that important. What do you think about that? Maybe we can just implement a high security standard, like the standard that is used for a credit card in banks. So that's PCI DSS standard. What do you think? What's better? Does to implement a good security standard, or to not keep the messages at all?
You know, my first question is that when we want to record something, it is good to ask the participants or let them know and make aware about that all the things are recorded. And as long as you don't get the commitment of all of participants, it is rather, how to say, not the way to go forward. So this is first step to get such application to real life. Then I would rather store it centrally and give the access to those who participate in the meeting, not just use it for any other purposes. I think that we should take care about this GDPR rule really. And I think that in that case, the measures that are standard, used as a standard for access in organization can be applied. So it is just like having a list of those who can access the information. But it would be interesting on the other side to keep locally my own comments, yeah, and make them, how to say, possible to use together. So, for instance, when I open the text or the text record of the meeting, immediately my notes are open and I can see both of them. Yeah.
Yeah.
Karolina, what do you think about the impact on productivity and efficiency? This idea about pushing someone to react to some comments, some hashtags in the script you will receive as a user.
I would say that maybe from the more emotional and social side, that it could be, I can say, frustrated for those who delivering the webinars, the presentation. Yes, that it could be frustrating that somebody is not listening to me. Yes, and I'm prepared the materials, I'm providing the meeting, and then nobody is listening to me because there will be some notes. Yes, and I can say does a short notes after my meeting, so it could be frustrating. But on the other hand, I also would like to have the influence what will be the content of the note. Yes, so I would like to somehow approve it after that, if it is I can say the essential of my material of my presentation, or I would like to highlight maybe different aspects, yes, of my presentation. So maybe kind of the approval, yes, after that. The revision and approval, it could be also implemented. But also taking into consideration that you have a lot of meetings, and somehow you have two meetings in a I can say in a one time, yes, and you don't know what meeting is more important, yes. So maybe it's you could maybe more work on added value for the user, yes. So it's not the fact that meetings are boring, yes, and we just simply not listening, but to work more on this added value, yes, because I don't know, you have a lot of meetings, you would like to participate in more projects, but you don't have a time, so it's kind of the solution for that situation also.
I mean, it's not always that the meetings are boring, but sometimes it's just hard to be focused for very long period of times. If you have like 4 hours of meetings in a row, that's tough.
Guys, we are in extra time, just about 30 seconds. I wanted to ask Krzysztof, who was who was going and wanted to say something. Krzysztof, could you add something to this comment?
I'm very interested in two pieces of this solution, because Michał, you mentioned that you will be able to find some kind of importance of so what is the most important part of the meeting, and I'm wondering if you have an idea how to solve it, because I'm guessing that it might be, different set of meetings. It would be different set of, importance for software development team, and a bit different story would be for, lawyers, right? And they will have different set of importance during their meeting, and it would be the challenge. And second thing, if you have also considered language support, because in a business language, it's a very tricky part, because we are using some kind of shortcuts, some kind of terms which are very specific for business and not very well supported by general purpose language models. So just wondering of those two topics.
Okay, thank you guys. Thank you, Krzysztof, for these remarks, and we got to finish this feedback session for today. Michał, wish you all the best, and have a great time coding this evening and tomorrow, and we'll see each other tomorrow on evening in the grand finale. So guys, next point of the agenda is the webinar with Google. We want to switch to this webinar. See you later. See you tomorrow. Ciao. Bye.
Hello, everybody. I'm hoping everybody can hear me. It sounds like we're ready to go. My name is Kevin Nelson. I'm a developer relations engineer with Google Cloud. Let me go ahead and share my screen here. Okay, hopefully you can see that. So I've been at Google, just real quick on me, I've been at Google for 7 years. I joined Google originally as a product manager. I was lead product manager for the backend of Google Drive for a couple of years before moving over to the cloud side in this developer relations role. So with that, let me jump in. I'm going to talk today about why developers should care about Google Cloud, and hopefully show you a few things that you might find interesting. So I'm going to go back to the very, very beginning of Google. This is Google's mission statement: organize the world's information and make it universally accessible and useful. That's a pretty broad statement, and it's led Google down this path where we've created a large number of applications that people use on a broad scale. Most people, when they think of Google, though, they probably think of this, the simple Google search box, where you go to enter queries and hopefully get results back that are what you're looking for within a few hundred milliseconds. But when I see that Google search box, I see kind of behind the scenes. I see what is going on to make all that work, all the machines, the network, everything else that goes behind being able to deliver those queries at that incredibly rapid pace with high accuracy. So, but developers quickly ask is like, well, so what? I mean, so Google's been doing all these things. We've built, the search and Gmail and other applications, but other companies, other developers really aren't trying to be Google. So why is it important? Why is it interesting for people to want to run on Google infrastructure? Well, you're not trying to do the exact same thing as Google, but you are trying to make the same kind of choices that Google made originally when we launched Google Search back in 1999. You want to be more data-driven. You're trying to focus on the things that matter, those things that are unique business value that you can provide to your customers. You want to make sure that you're as secure as you can possibly be. Nobody wants to end up on the front page of the New York Times with the latest hack. And of course, you want to grow your business while managing costs all at the same time. So cloud is a differentiator that allows you to do things better, to do things faster. It really all comes down to your software delivery lifecycle. Research has shown that being able to launch code quickly and reliably are key measures of success, both for software development teams and for organizations. So the National Institute of Standards lists these five characteristics of what it means to be in the cloud: on-demand self-service, resource pooling, rapid elasticity. And what's interesting, though, is when you poll IT professionals, you find that only a relatively small portion of organizations have all of those capabilities available. And so it's really critical to gain the full benefits of the cloud that you have these characteristics. So like, for instance, if you have to open up a ServiceNow ticket in your organization in order to get a test environment, you're not getting the full benefits of what you can by having your architecture run in the cloud. So what are the traits that distinguish Google Cloud from other cloud providers? There, of course, we have competitors in this, both large and small, and still most infrastructure is run on private data centers. So why do people want to move to the cloud, and what choices are they making to decide where to run those services? So the first is infrastructure modernization. You want to be able to ensure that you have a place that you can guarantee your software is going to run reliably and be able to run it when you want to be able to serve the needs of your customers. You need to be able to manage all the data that you have. And this can include everything from enterprise resource applications like SAP HANA down to small databases, could be anything. We'll talk more about databases in a little bit. You want to be able to take that data and be able to analyze it to draw business insights. Today, that's harder than it should be. And being able to do this can allow you to make decisions faster and better. And of course, you want to be able to flexibly, reliably, quickly build new applications to serve the needs of your customers. And that may be, again, in an on-prem data center, or it may be up in the cloud. So let's go through some of the infrastructure stuff. Most companies, what brings their unique business value is not about building and operating computer infrastructure. No CEO has ever said, awesome job maintaining our DSS entries, or great job building this container orchestration system. But that's exactly what Google is. Because we've been operating at such a massive scale for so long, we have learned what's worked and what hasn't worked along the way. Back in the very beginning, there weren't tools available that allowed us to, or that allowed anybody to be able to query the entire internet and store multiple copies of it, and then analyze that data and keep secure. So Google had to invent all that along the way. And many of those tools Google has open sourced those, and they become the foundation of the modern internet, things like Kubernetes. We have to be where the customers are. So today we have 25 regions across the globe. Each one of these regions has at least 3 independent failure zones. So with separate power, separate network ingress, egress. So even if someone comes in with a backhoe and trenches up your fiber optic line, that application, that data is still going to be accessible wherever you are. There you see a bunch of white circles on this map as well. We continue to grow extremely rapidly, and we're launching more and more data centers, again, to be able to get that as close as possible to the customer. The latency matters when you're using these types of applications. Along with all of the actual data centers, we also have the world's largest private network. These maps show Google's fiber optic network connections. Google has laid their own fiber optic cables across many of the world's oceans, again, to ensure that we can keep that latency as low as possible, making sure you have access to your data and your customers have access to that data wherever they happen to be. And again, on the idea of most companies it's not their key competency to build and run this type of infrastructure. You'll see up in the upper right-hand corner that these cables in the ocean have to be actually shark-proof. Not something that most people would think about, but we've had the experience and learned how to keep those things running secure. And the network really matters in this case. For most cloud providers, and just if you're running applications on any kind of a third-party service, you're probably connected to that over the public internet. And that can impact the latency of the use of those applications. With Google, the customer enters onto the Google network at their closest point of presence, somewhere likely within a few hundred miles of where they are. It then transfers across Google's entire private network behind the scenes and then drops out at the data center where that application is being served. So this guarantees the quickest possible access to your data for your customers. Now, getting into compute, Google Cloud offers a complete range of compute options for you. Starting with Compute Engine, you can upload existing virtual machines, take them right out of your data center, called a lift and shift, move that up and run it exactly as you do today, but not having to worry about the underlying hardware, the OS upgrades, or the other factors that are required when running physical infrastructure. Then up into Kubernetes, which running containerized applications is where most modern development is going today. And then on up into complete platform as a service things like App Engine and my new favorite, Cloud Run. I'll talk more about Cloud Run a little further in the presentation, but effectively what you're doing there is you're virtualizing even the container orchestration side of the application. You can take any containerized application and just let Google worry about how to scale that and where to put it. We offer extremely flexible virtual machines. So you're not just limited to a handful of pre-configured machines. If you need if your application requires more memory or more CPU, or if you need a GPU on some aspect of the application and not on others, you have complete flexibility to do that, which is it's a great way of saving money and making sure that you have the exact resources you need to be able to optimize the impact of the application. One unique thing on Google Cloud is what we call live migration. With live migration, Google is able to completely upgrade the operating system, change out hardware. You can move virtual machines running with zero downtime. So you can make those choices for yourself if you want to do certain upgrades, or if Google needs to, say, update the OS, change firmware, swap out bad hardware, we can do that with zero downtime to the users. I know you've been working already on code for the hackathon for at least a couple of days now. So I know you're already familiar with this with the Google Cloud Console. So I'm just going to skip over this slide. Some of you may be interested to know that Google is the largest purchaser of renewable energy. We try to be good stewards of the world's resources. We've been carbon neutral since 2007. And in 2017, we actually reached 100% renewable energy. But we still have more to do in this area. We're working now to have minute by minute being able to have all renewable energy powering the services. But there's still a way to go in that. That's a tough one. We have sources all over the world of renewable energy projects, including a newest one in Taiwan, which is particularly difficult because it's in a small urban area. So it's an interesting solar application. And wherever we have data centers, we are in the process of adding more and more renewable energy there. Okay, so the biggest thing I think that people consider when they're thinking about the cloud is security. We used to get asked, it's like, oh my goodness, I can't imagine going to the cloud because how do I know if it's secure or not? Well, that's really been turned around. Today, it's almost impossible to stay up to date with all of the potential vulnerabilities and resources required to keep things 100% secure. Google, of course, has been a big target for a long, long time. So we've developed special techniques, special tools to allow us to operate the infrastructure and protect it from any kind of attack. So this is the typical view of security. You build a big wall with a moat, and you have your nice open network inside where everything is safe and sound. But the reality is a little bit different than that. It's no longer enough, especially in over the last year where we've all been working from home. How work has changed, and you need to be able to give access to resources, to data, to compute resources, to different individuals, to different applications, to different organizations, and you have to be able to do that wherever they are. So security has to change to be able to handle that type of flexibility. So Google has a simple approach to this: trust nothing. And so what does that mean? It means that we have to take a defense in depth approach to this, starting with the hardware. Google builds, most Google infrastructure runs on Google built hardware, custom Google hardware, down to individual chips on individual boards that are security chips that guarantee that the firmware running is exactly what we think. If you're loading up an image, you can guarantee that those images are exactly what you think they are. No one is sneaking anything into the process. So you have to take this at all different levels in operations and identity management and all of the services. And you see the impact of this when you hear about some of the big public hacks that have happened. Google researchers, our so-called zero-day team, identified what subsequently became known as the Meltdown Inspector vulnerabilities. With live migration, Google was able to update the systems across the entire Google fleet with zero downtime to users. And the latest big hack that's come out is the SolarWinds hack that allowed hackers unrestricted access to many top-level federal agencies inside the U.S. government, and a lot of huge companies, including Microsoft. Google was unaffected by this, partly by how we work with third-party software. We do our own security audits on all this, and everything is isolated so that it only has access to areas that it needs. And that's that approach of not thinking about security as a moat, but allowing granular access to only the resources that are required for that application to work. So data management. Of course, data is the thing that Google is best known for. The first question I always get is, oh my God, I can't imagine going to Google because you're going to sell my data and I'm going to start seeing ads against what we do. Definitely not true in Google Cloud. Things you do on Google in search and and Gmail and Maps and all that is very, very different than Google Cloud. Google Cloud, your data is your data. There's no government access provided. No one else has access to it but you. You can even install your own security keys, so even Google can't see the data, even to help you with support cases, for instance, unless you explicitly provide access. We have something new that's happened in the last year or so. Inside Google, there's always been a tool called gin logging, where anytime an engineer needed access to customer data, that access was logged and could be audited. There have been some interesting cases where, Twitter employees have gone into accounts of celebrities, for instance, and accessed the data. Larry Page couldn't do that at Google. It's just not possible because of the protection and logging that goes on. Everything gets privacy reviewed. Any data access is always logged. And now customers, Google Cloud customers, have access to that data so they can see exactly if any Google employees have accessed their data and why. So sometimes we have to access data. Say if you have a support call, you need help with something, or we're looking at a bug, we may contact a customer and say, we'd like to be able to review some of your data to help with this bug, and they can provide access and they can see exactly who accessed it and when. We also protect your data from your own employees. You can imagine someone on a support call where they may have to verify a customer's social security number or phone number. With data loss prevention, you can actually protect that information directly in the screens that those employees are using. So you can make sure that employees aren't writing down information or taking screenshots of data that could potentially put your customers and your business at risk. This is all done using machine learning, and there are many, many different types of PII, or privately identifiable information, that you can automatically choose to hide in that way. We offer a complete range of databases, both fully managed, and if you want to run the databases yourself, you can of course run those up in virtual machines or containerized applications. We have everything from a managed Redis service for in-memory database up through NoSQL, document databases like Cloud Firestore and Bigtable, on up to relational databases. And at the very top end is a horizontally scalable database called Spanner. Spanner is really interesting. It's almost magic. And the way it works is that every node in a Spanner database has its own atomic clock. So this is how transactions are serialized across a horizontally scalable database. So Spanner is the backend for almost all Google services at this point, and it's available for enterprise databases for Google Cloud customers. And say it's quite magic in the sense you can do standard SQL queries and normal ACID transactions, and this all works, and it can scale up and down as required to meet instantaneous demand. Smart analytics. Data, of course, is the key to everything that you're doing to run your business and to manage it effectively. And Harvard Business Review, did a study and found that less than 1% of unstructured data is analyzed or used in making business decisions. Now, I don't find that particularly surprising because unstructured data is things like video and audio, images, and those things have been traditionally much, much harder to organize and gain insights from. But what did surprise me is that less than 50% of structured data, this is databases and spreadsheets, are being used today to make decisions. And that's because gaining access to that and organizing it and looking at the relations and how that all works is hard. And in the traditional way companies would go about this, they would have a data warehouse, which is a separate big bank of computers sitting somewhere. And you have to manage that just like other infrastructure. You have to upgrade it. You have to manage it for scale. You have to decide how resources get allocated, who has access and when. It costs money and takes time to add more storage, to add more compute capability. People have to figure out when and where they're able to use that data. And so it ends up being a huge burden on IT staff for maintaining that type of infrastructure. What's better is to be able to make that entirely serverless so that all you have to think about is that data and what insights you want to draw from it. The tool we offer for that is called BigQuery. And this is it's an internal tool at Google called Dremel. When I first joined Google as a product manager, I was astonished. I was trying to analyze sharing patterns in Google Drive. And I was planning this big system to be able to draw the data and build a separate table. And the TL on the backend team said, you can just go run a query in Dremel. It's like, no, come on, it'll take months. No way. He's like, nope, go give it a try. And in 15 minutes, I had the beginnings of the answers that I wanted. BigQuery is an astonishing tool. It allows you to store exabytes of data and do petabyte scale queries in minutes. You can do gigabyte scale queries in seconds. So it changes the way you think about data. You no longer have to schedule these batch jobs to run overnight, and then you can, then draw some table, maybe draw insights from some kind of a dashboard that gets updated every day. You now have instantaneous real-time access to the data, and anybody can access it, again, depending on the access that you provide for people to be able to do that. These are some of Google's billion user products. There are now 9 of them, and 9 of the top 11 applications used worldwide are by Google. The other 2 are Facebook and Instagram. Instagram, of course, is a Facebook application as well. But all of these applications now are enhanced and built on top of machine learning. Machine learning for probably the last decade has really changed the way Google develops applications. And those tools now are available for businesses to be able to draw their own insights. And it's an absolute game changer. So what you're looking at here is a tensor processing unit, V3 pod. There are 1,024 TPUs, these tensor processing units in that. A tensor processing unit is custom silicon designed just for doing machine learning. Effectively, there's a big matrix multiply engine that allows you to do machine learning training and inference at scale that just isn't possible without it. Today, Google offers a wide range of options for doing machine learning. Of course, the traditional way is with a data scientist or machine learning expert, where you build custom models. But there are not enough data scientists or machine learning experts in the world, and never possibly could be, to be able to develop models for all the potential applications. So a few years ago, Google also introduced pre-built models. These are they're APIs that allow you to submit data and draw insights from that. So we have these ML APIs for vision, video. You can submit a picture and it will tell you what's in it. Natural language. You can take apart a sentence to understand the semantic meaning of it. You can do translation from between over 100 languages. And up until maybe 5 or 6 years ago, translation was pretty wonky kind of thing. You'd get very strange translations because it was just looking at words and what they mean. But there's a lot more semantic meaning inside phrases, and converting that into other languages is really challenging. When we changed the backend infrastructure to use machine learning to analyze the speech patterns dynamically, it completely changed the quality. And now translation and translation between languages is now remarkable. Still not perfect by any means, but you can do this for your own applications, and you can even include your own custom jargon for your business specific tools. You can build a custom model that includes that. And the way you do that is with something now called AutoML. AutoML builds on top of a pre-trained model and then uses transfer learning to incorporate the additional custom changes that are required for your specific application. In this one image I have here, the traditional Vision API would be able to tell you that was a cloud, but it would not be able to tell you what type of cloud it was. So by building a custom model, we were able to then do cloud analysis and do that with very, very high accuracy. One simple example, but there are lots more. So these are all of the places where you can use AutoML. So again, in vision, in language, translation, you can even do with Dialogflow, you can write conversational tools, text to speech and speech to text. The voices now, like if you use Google Assistant or Alexa, the output of those now sounds extraordinarily human. And that's because the machine learning has been applied on the output as well to match those waveforms, so you don't get clicks and weird breaks in the language. Again, if you use Google Assistant or Alexa or any of the other voice tools, the ability to understand human voice now is remarkable, and that can be utilized for like phone trees. So people aren't having to do press 1 for support. You're able to be able to have a human talk conversationally and be able to understand what's going on. But I think the most interesting place to start for most developers, for most companies, is with structured data. AutoML tables, I think, again, kind of falls into the magic category. You can take any structured data and pick one column, for instance, of a spreadsheet or one column of a database and say, I want to predict this value. And AutoML tables will go through that data, build a custom model on top of that, and then you can then submit data real time or in batch, independent of that, and then make predictions. And there are huge use cases for this for every single business. In retail, you may want to predict the likelihood of stockouts or optimize inventory. You may be in finance, you might want to predict fraud. You got a credit card. How likely is it that you're going to get that something's bad there? So you can manage risk. In marketing, you want to predict future lifetime value, or how likely is that customer to churn. If you have that data, you have the data from the transactions throughout the weeks, months, years of your business. You can just take that and literally with the click of a button, use that data to draw insights for future transactions. This is a tool that is, again, to me, it kind of falls into the magic category. It's remarkable, and anybody can use it today to draw insights in whatever you're trying to do. And all of this runs on, I mentioned the TPUs earlier. This is showing a version 3 TPU board. I don't know if any of you have been to any of like Google I/O or any of the big shows. For the last couple of years, we would bring in one of the racks. These are big racks. They're 9 feet tall. The complete TPU pod that I showed a few minutes ago is 36 feet long. Together, that V3 pod delivers over 100 petaflops of compute power focused entirely on machine learning training and inference. But now we've just introduced the V4 version, and this cranks it up another notch. The complete V4 pod now delivers 1.1 exaflops. That's 1 quintillion, or 10 to the 18th floating point operations per second. That's equivalent to 10 million laptops. What Google does at scale, and for our own applications, and then making it available to cloud customers, this type of machine learning capability would be impossible without the custom silicon. There aren't enough general purpose CPUs available to do it at the scale and speed required. So with Google investing in this type of custom silicon, it provides those capabilities, say, not only to Google, but also to Google Cloud customers. Application development is near and dear to my heart. I'm fundamentally an engineer. I spent the first 20 years of my career as a system programmer, writing schedulers and things like that. And so, for me, I don't want to deal with the hardware at all, quite honestly. I just enjoy the coding part. But moving to the cloud is a challenge. Companies, a lot of big applications that are behind the scenes at many, many massive, well-known companies, still written in COBOL, for instance. How do you take those and move them to the cloud? Companies don't want to get locked in. It's like Before it was databases or particular type of servers. Now you want to maintain that flexibility. You don't want to get locked into Google or AWS or anybody. You want to have the flexibility to choose the infrastructure at the time you want for the particular application that you're doing. And something new is going to come along again. You don't want to get stuck when that next thing comes along. And of course, more and more customers are employees too, are accessing your applications on mobile devices. How do you manage all that? So what do developers want? What do you guys want? We always want to ship great code. And that's where a developer's mind should be. You don't really necessarily want to think about managing Kubernetes clusters or what the configuration of a virtual machine ought to be. So, how do you go about doing that? I mentioned earlier, Cloud Run. Cloud Run is my new favorite tool. What it does is it virtualizes away the idea of Kubernetes. So you containerize an application and you load it up in Cloud Run and you let Google manage it for you. If you get a spike in traffic, it will automatically scale up. You only pay for what's being used in 100 millisecond increments. So if you get a big spike and then it drops back down a few minutes later, you're only going to pay for that spike in traffic there. You don't have to think about that on a Kubernetes scale or on a virtual machine scale where you have to pay for that infrastructure behind the scenes to be able to handle those peak loads. It just works. And it provides awesome capabilities for deploying applications as well. So one of the key things that Cloud provides is the ability to roll out new versions and test those before deploying it across your entire fleet. So in this example, we've decided we've deployed a new version called B, and we want to take 5% of that and run it in Canary. So 95% of the service is still running on a version that we know works, and we've deployed a new version, and we're letting 5% of users try that, and we're gonna look at the logs, we're gonna look at the errors, and with Cloud Run, you deploy it, you say what percentage you want to do, and you click a button, and you're done. You don't have to think about anything else. You also have a lot more flexibility than that. You can choose to split traffic based on many, many different characteristics, including user agent. So you may say, I want to have just iPhone users testing a certain application, or they may have different capabilities on the iPhone version than on the Android version. So you can redirect that traffic to exactly where you want and deploy versions and manage that. And again, you can manage the applications, the log, you can check latency, everything on that type of granularity without ever once thinking about the underlying infrastructure there. And at the high end of this, we also offer a service called Anthos. Anthos is entirely based on open source tools, Kubernetes, which again, Google introduced back in 2014. Istio is also called the Anthos Service Mesh. This is a tool in between that allows you to monitor the interaction of services in real time across cloud-based applications. And then Knative, which allows you to take containerized applications that were designed for Kubernetes and run it on your own infrastructure. You can run it on your laptop if you want to. And this provides some unique capabilities. So with Anthos, you get this single control pane for your applications. You take any containerized application or a VM-based application, deploy it in Anthos, and of course you can then run that on Google Cloud, but you can also run it on other clouds. You can run it entirely on AWS if you want to, or you can have it partly running on another cloud provider and partly on Google. And you can run it in hybrid mode on your own infrastructure as well. So this is critical. There are lots of applications, for instance, in regulated industries that require services to be run in approved hardware. And Google has lots and lots of regulatory approvals for many different types of applications like FedRAMP, but there are always going to be either regulatory requirements or just desire that for some applications to be able to run on your own infrastructure, inside your own data center. And that's fine. But being able to have that single view to that application, if you're accessing third-party services or other data sources, you can do that with Anthos. And then, again, be able to deploy it where you want to. You're not locked in. You are, this is all running on open source. And so you can decide exactly how and where you want to run it. So just to kind of bring things back, how is Google Platform different? Well, we have the secure, reliable infrastructure. Google has some of the top security researchers in the world, definitely the largest team. Make sure that your software is always going to be able to run reliably and safely. Being able to scalably manage your data and with fully suite of managed databases. This is not just data, but also compute, being able to scale things up and know that no matter how big you get, it's Black Friday, you may have a several 100% peak in traffic on certain days, certain times. Your application may get mentioned by a celebrity on Instagram, and all of a sudden you're getting 100 times the traffic that you're used to. By being able to scale these things reliably and quickly, it gives you the flexibility, the confidence to know that you're going to be always servicing the needs of your customers. Being able to unlock the value of your data. All that data is sitting there. It's there available for you to draw insights, to make informed decisions, to grow your business faster. By using things like BigQuery, you're able to provide much, much more capability across the business needs. And then being able to run either, say, on-prem or on other clouds, giving you that flexibility to do what's right for your business. And again, most importantly for me as a developer, to empower developers, make sure that they have the tools they need to be able to develop applications quickly, reliably. And there's a, here. So is that it? We've got all this great hardware, all this great software running. Is that all it takes? Unfortunately, no. It also takes something that I've come to call radical transparency. A big part of what makes Google an innovation engine is this idea of transparency. As an example, in Drive, when I was a product manager, if we're working on a design document, everybody in the organization has access to that, from the newest engineer to the most senior directors and leadership. They are commenting. They are in there real time working on that. As a product manager, I want the best ideas from everybody to make sure that we're getting the best results out to our customers. We start that early. We don't have the great expert go off for 3 months and write the golden design document. Because once you've done that, you have so much invested in that if you find a better way, it may be too late to change it. By getting everybody involved early, you're ensuring that you're getting the best ideas and you're going to get the best results. After we deploy stuff, we measure everything. We measure everything from speed of software delivery lifecycle up through error rates and latencies and everything in deploying that application. With that data, you can draw insights to make things better. And when problems pop up, as they inevitably do, we do something called what is called a blameless postmortem. And this truly is the key. And when I first came to Google, I thought it was remarkable. And I've seen the results, and it is remarkable. When a problem occurs, Google does not consider that the person who wrote that code or the ops person who happened to be on call when that problem occurred is the source of the problem. The problem is that the system we use was broken that allowed that error to creep in. So we go in with this postmortem philosophy, we dig down, figure out exactly what the root cause was, and we publish that. And those documents are, again, widely distributed. Everybody in Google can read those. So it doesn't just help your team, but it helps other teams across the company. And kind of remarkably, some of the engineers who've caused the biggest problems at Google are also the most celebrated because they wrote great postmortems. So building up the culture that allows that transparency happen is a critical factor in being able to get the most from running in the cloud. And I have, it's a whole nother story on that, but you can, if you're interested, you can go read more about that at cloud.google.com/DevOps. This is a topic that's near and dear to my heart. I talk about it a lot with a lot of large organizations, and I'm in the process with several on helping them rebuild this culture for them to be able to get the most benefit from this transformation that's going on. So I think you guys have already had access to this. If not, this is just a little cheat sheet that shows every Google Cloud product in 4 words or less. You can find that at 4words.dev. And with that, I see we're about 10 minutes to the hour. I will wrap it up. And if we have some questions, I am happy to do that. So thank you very much. So any questions at all? I think there's a chat here you could post in, or maybe there's a way to relay it through the organizer as well. By the way, I'm speaking to you from Los Angeles, California. So you guys are, I think, 9 hours ahead of me. So it's evening for you and morning for me. Yep, there's a comment here. Yep, it's definitely nice and sunny today. It's always sunny in Southern California. Not really, but it is a lot of time. So we're good. Well, it looks like no questions for today. So again, thank you. I have my Twitter handle up there. If you guys have questions after the fact, please feel free to send them to me, and I will do my best to get them answered for you. And if you have other questions on, if any Commerzbank folks are also, of course, welcome to go through the Google Cloud, your Google Cloud team, and we will try to get answers to any questions that you have. So thank you thank you very much. Good luck on the rest of the hackathon. I look forward to seeing all of the great applications that you guys come up with. So thank you very much. Bye-bye.